Good evening, ladies and gentlemen. Welcome to our Tech Talk. This evening is a very good evening indeed, as we are very loaded, fully loaded for tonight. Fully loaded in the meaning of yung mga speaker natin tonight ay talagang experts in the industry. But before anything else, I would like to say good evening to all our participants, to our honored guests and panelists. For now, may we call our our president of Metro West chapter for the welcome remarks, Engineer Henry Binarao.
Thank you, Sir Jomel. Good evening, my fellow IIEE members, and also to the National President present here, especially online in Zoom. May I call our VP Tech National, Engineer Jedfer De Castro, and of course to our Board of Governors at large who are present also here. And welcome to our another session of Tech Talks with the theme Safety Practices on Grounding System and Code Compliance Requirements. Tonight, we're focusing on a critical aspect of electrical safety that often doesn't get the attention it deserves: grounding system and code compliance. Proper grounding practices are essential not only for the protection of equipment, but most importantly, for the safety of everyone working around or using electrical systems. Grounding is the foundation of electrical safety. When grounding systems are correctly installed, designed, and maintained, they protect against electrical shock, reduce the risk of fires, and ensure that equipment operates reliably. However, it is not enough to simply understand grounding principles. Compliance with the Philippine Electrical Code is vital to ensure that we are meeting minimum safety standards and keeping both people and property protected. The Philippine Electrical Code and similar standards are continuously updated as technology advances and new safety data emerge. So staying informed and compliant is not a one-time task. It's an ongoing responsibility. In our session tonight, we are very fortunate that we invited experts from different industries as the panelists. We have Engineer Eric Tamundong, the Chairman of Electrical Safety Committee. We have Engineer Reynaldo Santiago, the Chairman of the Philippine Electrical Code Part 1. We have also Engineer Conrado Binondo, the Chairman Standards Committee. And of course, Engineer Adelino V. Garcia Jr., the Chairman of Training and Continuing Professional Development Committee. This session will be facilitated by Engineer Jomel Gabuna, the Chairman of Building Inspection and Technical Engineering Support of Metro West Chapter, and of course, our very own Engineer Manuel de Guzman, the former Chapter President of Metro West. So the panelists will cover key grounding practices, review code requirements, and discuss real-life examples of how non-compliance can lead to hazards. So let's approach with this a commitment to building safer, more compliant electrical system that protect everyone involved. With that, good evening everyone and welcome to our Tech Talk. Thank you.
Thank you, Press Henry. Tech Talk is brought to you by IIEE Electrical Safety Committee in cooperation with IIEE Metro West Chapter. And of course, this is made possible by our sponsors, American Wires and Cables, Philflex Wires and Cables, Hypertech Wires and Cables. In the electrical system, safety is top priority. In fact, we always say that the Philippine Electrical Code is first and foremost a safety standard, more than it is a technical compliance standard. In relation with electrical safety, our panel discussion will revolve on the issue of grounding, a topic most often set aside or neglected, which, if not addressed properly, may affect power system reliability, power quality, and safety. Our Tech Talks topic for this evening, safety practice on grounding system and code compliance requirements, an overview of which will be discussed by our panelists: grounding system design and installation, project management and grounding power systems, grounding system and international standards, and grounding system in compliance with the PEC. And so, without much further ado, let me introduce our panelists one by one. Talagang maswerte po yung mga nag-join by Zoom kasi bibihira natin makasama ang mga chairman of various committees and industry experts. Napakahirap po niyan, kaya napakaswerte po. Mas maswerte po kami nandito sa IIEE office kasi makakausap po natin sila diretso. Our first panelist is a graduate Bachelor of Science in Electrical Engineering from Southern Luzon State University, obtained his master's degree in management, major in engineering management from Manuel and Verga University Foundation, a Doctor of Philosophy in Management from the Lyceum of the Philippines University, Batangas, a professional electrical engineer with more than 2 decades of experience in manufacturing operations and engineering and maintenance, project management, engineering compliance, energy management and energy audit, professional practice in technical consultancy, teaching and training, expertise in electrical system design and assessment, industrial and manufacturing plant operations and maintenance and project management, former 2023 IIE Governor for Southern Luzon Region and the current 2024 IIE Electrical Safety Chairman. Ladies and gentlemen, Dr. Eric Tito Mondong, PhD. Sir, please join us in front. Our next panelist has more than 45 years of successful track record and experience in power, energy, and business executive management, power and energy engineering systems integration, power generation development and regulatory compliance, EPC execution and contracts management, power infrastructure asset management, and pioneer of the Philippine independent power generation business. He is a specialist in power engineering and system integration, power generation plant, transmission and distribution design and construction, EPC construction and project contracts management, power generation, transmission and distribution operation and maintenance, power system protection and control. He is currently the chairman of IIEE TCPD Committee, chairman of IIEE Audit Committee, IIEE Specialty Practice Committee member, and member also of IIEE Advocacy Committee. Ladies and gentlemen, Engineer Adelino V. Garcia Jr., PEE, fellow member, IIEE. Our third speaker, he is a professional electrical engineer and the first Filipino to receive in 2022 the IEC 1906 award from IEC Geneva, Switzerland. Yun lang naman ang tinatanggap niyang award sa Geneva, Switzerland. In recognition of his long-term contribution with deep expertise in electrical installation and protection against electric shock, IEC 60364 and Basic Safety Publication, IEC 61140, and especially IEC TC64 plenary meeting. He has gained wide experience in the design, manufacturing, testing, and commissioning of medium voltage and low voltage switchgears in Riyadh under licensee of Schneider Electric and Siemens. After his stint abroad, he put up Elecdesk Trading and Technical Services, specializing in generator synchronizing control systems. He is a registered expert of IEC TC64 WG43, the chairman of BPS TC77, member of TC69, and of IEC National Committee of the Philippine Standards Management Board, member of BPS TC10, and of UPEEP, Board of Trustee of NPAP 4.0, and the chairman of IIEE Standards Committee. Ladies and gentlemen, Engineer Conrado C. Binondo, professional electrical engineer. Sir, please join us. Our fourth panelist is a graduate of Bachelor of Science in Electrical Engineering, postgraduate diploma in management, Asian Institute of Management, master's degree, Master of Engineering in Electrical Engineering, master's degree, Master of Science in Electrical Engineering, academic units, Doctor of Philosophy in Technology Management, candidate, 2017 IIEE Metro Manila South Vice Chairman, former member of the Academe, former chairman and senior member of IIEE Power and Energy Society, Philippines Chapter, IIEE senior member, IIEE Standards Committee member, currently the IIEE PEC1 chairman, a professional electrical engineer with more than 20 years of experience in the field of electrical engineering, planning, design, construction, and supervision of projects in Asia and in the USA. Ladies and gentlemen, Engineer Reynaldo Santiago, PE, who will join us in a while. Okay, for our first panelist, may we call on Engineer Eric Tamondong. By the way, ladies and gentlemen, this is different from the typical presentation, technical presentations. In here, we encourage participants to join, participate, ask questions, clarify matters in the presence of our experts. So this is more of discussion, open discussion after the presentation. And after the presentation of the four panelists, there will be a question and answer and open forum. Okay, thank you, sir. Take it away.
Thank you, Sir Engineer Jom. Good evening, everyone. Good evening, dear participants at Zoom and here at the IIE National Office. Okay, we'd like to start with what you call the basic principles and introduction when it comes to grounding, as we consider the safety practices on grounding systems and code compliance requirements. So, everyone or kanina binanggit ni President Henry as Engineer Jom about the safety practices when it comes to grounding, which is the most what do you call that? One of the most important and foundation of our electrical system, but mostly neglected din. As we consider, dapat tandaan natin that we have what we call technical compliance, going to performance, and ensuring safety. So personnel safety. That's the highest form of importance that we can consider when it comes to our practices, especially in the electrical safety and of course, grounding and bonding. So let me proceed with my slide. Okay. Let's start with the principles of grounding system. This is to establish, of course, a low impedance earth electrode system, or the low impedance path of amounts of currents in our system. The low impedance path coming from an unwanted current in our system. We ensure the grounding has a low resistance connection to the earth or to the ground that we speak. typically achieved through a network of interconnected grounding rods, plates, and mats. Through, of course, proper bonding and grounding connections in our electrical system. Uh, Considering as well, we have typical standards, as you may know, that the resistance should be maintained at below 25 ohms. Or we may say that grounding can be maintained lower than 5 ohms, and sometimes in some specialized industry and practices, it's below 1 ohm. Second is we maintain, part of the principle is we maintain equipotential bonding. The equipotential bonding, as we know, is the interconnection of conductive parts, including the metal structures, equipment enclosures, piping systems, establishing a common reference potential to prevent voltage differences. This is very critical when it comes to a certain fault that may happen in our system, that we ensure that all metal parts or metals in our system, uh, such as structural steel, water piping, of course, equipment enclosures, which are metals, as we establish the bonding between them and connection, effective connection to the ground, we are to maintain the the reference potential and prevent voltage differences. If we maintain and maintain zero potential, zero voltage differences, technically we are managing that also maintain a zero amount of current. No, whenever we have uh, whenever we have system system faults. Yes. Next part of the principle is that we implement surge protection. The surge protection, we incorporate our surge arresters, lighting protection, transient, or the TVSS, or the transient voltage surge suppressors, to safeguard from the transient over voltages and protect and the protection of our sensitive equipment. Given that at any system, you know, every fault that might happen induced by a certain electrical equipment, as we arrest all and coming from the system itself, so we arrest this surges, you know, and transients in our system through the help of the grounding system. By the way, nagkakaroon po tayo ng interchanging definition or interchanging uh, description when it comes to grounding. Grounding refers to the NEC or the Philippine Electrical Code as we used to. Kapag narinig naman natin yung earthing, we are actually referring to the IEC standards, for which in the Philippines, mostly tayo po, we are exposed to this kind of standards, so different standards. Dito na lang sa Philippines, we actually adopt what is applicable to us. But primary, as to give us a consideration, we are actually considering Philippine Electrical Code as the primary reference. The fourth grounding principles is that we consider soil resistivity. The soil resistivity is about checking what is coming from our system. We check the soil resistivity. That is, in turn, we are to consider the type of grounding system that we're going to use. If we'll be needing supplemental grounding, are we needing a mat, or are we needing a certain grounding system, which is applicable to achieve a certain level of resistance. And lastly, we consider proper conductor sizing. We consider the sizing of conductors for specific application. Will that be an equipment grounding, or will that be a system grounding? We proceed to the next. Oh, what happened? Oh, sorry. So as I mentioned, we have the grounding types. We have the system grounding, wherein the neutral of the system is effectively connected to the ground bus, going directly from a grounding electrode conductor going towards the ground rod. So that is what you call the system grounding, specifically maintained or installed in the source side. Then we have the equipment grounding. The equipment grounding, which involves directly connecting the metal parts of an electrical equipment, such as metal enclosures or frames, to the grounding system, of course, as we provide low impedance path for fault currents and ensure the proper operation of OCPD, of our OCPDs. Again, ang highlights ng electrical practice natin is all about safety. When it comes to safety, this is a safety consideration when it comes to grounding. Sabi nga kanina ni President Henry, it's the foundation of our practice. Electrical safety. And grounding of which, grounding our system plays a major role. As we provide proper earthing or grounding connection of our electrical system going to the ground, we dissipate unwanted currents or faults. Electrical isolation or safety of our personnel, lightning protection. We have enormous amount of current coming from this. And lastly, the application, which is very important to hazardous environments. We will talk about hazardous environments in the next slide as part of the application of our grounding. Installation best practices. As we go through, we have the soil testing. Kanina, we mentioned about what we call the soil resistivity, as we are to determine what type of soil are we dealing with. And of course, as we deal with this type of soil, we are to provide appropriate grounding installation and design to our system. The grounding electrode selection, hereby we having the standard of grounding electrode. It has to be driven 8 feet below the ground. If it's not yet driven, we have other methodology. It should be at 45 degrees. No? Having a length of 8 feet pa rin. Then we consider it as the directly buried type with a 2 feet yung depth niya, and then of course specific connection pa rin to our system. We have the proper electrode placement as we discussed, yung mga 3 methodologies: driven to the ground, 8 feet below, from the tip up to the top layer or the top exposure to the ground, and then we have the 45 degrees, and lastly we have the directly buried or in a concrete encasement of a 2 feet depth. Grounding conductor size, as we mentioned, ang grounding conductor size natin is referred to the Philippine Electrical Code, that is, as it is available for grounding equipment, which is ang basis natin is the coming from the Philippine Electrical Code. The basis is the size of the OCPD, and when it comes to system grounding, we're considering the size of the grounding as from the system from the largest size of the conductor. We have corrosion protection as we ensure basic maintenance ito, we consider the best practices as the corrosion should be considered, the corrosion protection in our system, kasi it will induce open system, or ibig sabihin hindi magiging connected yung system natin. The grounding connectivity. Accessibility and inspection, we install our system as it is to be maintainable. And lastly, the bonding and interconnection, as we ensure the proper electrical connection between electrical equipment, or what we call separately derived systems. What are the techniques for effective grounding? We have the following. Of course, proper electrical grounding, which starts with the design, the right specification, the right installation practices, and the maintenance part. We also employ earthing for electronic devices. If you're familiar with electronics, let's say sa semicon, no? So bawat personnel meron siyang mga ground strap, as we consider the electronic devices and components which are to be protected, and grounding serves as a strategy to ensure that we implement effective grounding system. Grounding for lightning protection, as we mentioned earlier, grounding for telecommunications, and grounding in industrial application. No. Separately derived system, telecommunication, radio and telephone, lightning arresters. So each has its own grounding system, which are technically having their own grounding electrode. Common installation mistakes, technically it's about grounding, improper placement of grounding electrode. We see in our practice kapag yung grounding electrode pinuputol, no? Kapag may tumama sa bato, ang ginagawa pinuputol na lang. That means that your grounding system is quite compromised. Compromised in the sense that nabawasan yung effectivity niya because we are actually providing an effective connection to earth or to the ground with a low impedance path as you are to maintain, let's say, lower than 25 ohms or lower than 5 ohms. Corrosion connection, inadequate conductor size. We ensure that the conductor size are likewise considered. Using grounding conductors with insufficient cross-sectional area leading to increased resistance and reduce the current carrying capacity whenever we have faults. Lack of bonding or there's an issue or there's a concern when it comes to interconnection of electrical panels. Sabi nga natin, we ensure the electrical connectivity of the grounding system of each of our electrical equipment through proper installation, which is what we call bonding. And lastly, improper soil preparation. No? We treat the soil for some instances, and the failure to properly prepare the soil, such as removing rocks, debris, can compromise Earth's ability to for the effective dissipation of electrical currents. So all of these installation mistakes are considering from design phase to specification, installation, then operations and maintenance. This is my last slide as part of the introduction. We have the case studies of successful grounding implementations, oil refinery and grounding system. These are mostly about the installation of grounding and bonding. We secure that on what we call hazardous location. So kasama po yan. Oil refinery, even powder-like areas, no, powder dust, explosive atmosphere. So we consider that. Also, on wind farm grounding, bakit malaki din yung consideration dito? It is because we have effective grounding system designed for a large-scale wind farm, safeguarding electrical equipment and preventing lightning-induced damage. So mostly in the field, farms, solar PV farms as well as wind farm, effective grounding should be deployed accordingly. Why? These are prone to lightning strikes. No? So every system should be considered when it comes to proper grounding and bonding. High voltage substation grounding, as we all know, sila na yung generating units. And lightning, mataas yung risk when it comes to lightning strikes. So we are to consider that we ensure that the proper grounding practices are being provided or exercised in these kinds of installation. And lastly, data center grounding upgrade. A comprehensive grounding system upgrade at a mission-critical data center, providing enhanced protection against electrical disturbances, ensuring uninterrupted operation. As we all know that these data centers provide data, ensure we have proper connection, as we consider electronics in their system para makonsider natin. And sometimes, most of the industry practice, less than 5 ohms or less than 1 ohm yung maintaining resistance ng kanilang grounding system. For this is just the highlights of of the introduction when it comes to safety practices when it comes to grounding. I will be endorsing back you to Engineer Jong for the next panelist to proceed. Thank you.
Thank you, Chair Eric. Ano, appetizer pa lang yan, ha? Solve na tayo. We encourage our participants here face-to-face and all those online, you can already send in your question. And later on, after the presentation of the four panelists, tsaka natin sila i-discuss with them. Moving forward, onwards, we now call on our second panelist who will discuss project management and grounding in power systems. As an overview, he will be discussing integrating safety into grounding projects, grounding as part of the overall safety management in power system projects, challenges in large-scale grounding projects, managing projects with complex grounding requirements, example graphia, e.g. substations, industrial plants, risk management, identifying and mitigating risks related to grounding system failures, case studies on project successes and failures, practical lessons from real-world projects that highlight safety critical issues. Ladies and gentlemen, please welcome Chair Adele. Sir? Sorry, can you please join us? As introduced earlier, Engineer Ray Santiago, PE, will now be joining us also. Sir Adele, you can also already proceed. Thank you po.
Are we good? Okay. Dito na ba ako? Or, sige, dito na lang ako tatayo. Okay. Can you cue in na lang yung ano natin? Lagay mo na lang muna sa abstract. As we are preparing for the material, maganda yung sinabi ni si Press Henry kanina eh. Earthing or grounding. Yung grounding is may sinabi kang maganda kanina, basis of everything eh. Basically, it's a basis of everything. So, yung ating slides, a few slides that we prepared for this evening, I would like to qualify a bit that marami nang sinabi ni Chair Eric dito sa mga slides ko. So, I'll try to focus on the more important issues kasi itong IEEE 80, basically our presentation kasi for tonight covers the IEEE 80 earthing and earthing designs. And mostly this IEEE 80 is, strictly speaking, it's for substations only. But in fact, if you look at the whole series of calculations and requirement, it's actually applicable to any power system. So that's why I would like to emphasize that while IEEE 80 is only for substations, the whole process of earthing design is applicable to all power systems components. No? So we'd like to cover the importance of a correctly designed earthing system. I'd like to emphasize correctly designed earthing system. Understand the various factors that drive the earthing design. Kasi ito yung pinaka-importante. We need to understand what drives the earthing design and understand how they impact on the whole design. Then we hope to understand the metrics of correctly designed earthing system in accordance to IEEE 80 and the corresponding risk and mitigation. And finally, some case studies that we may be able to glean from on real-world projects. I hope I can finish it in 12 minutes or 15 minutes. Because normally, this is a subject of almost about 16 hours kung talagang pag-uusapan yan. But then, this is a very short program. So I hope to cover very, very quickly the most important parts, which are the drivers or the design drivers. So the importance of correct earthing design to establish and as design basis highlighted safe limits of potential differences in a power system under fault conditions between points that can be contacted by the human body. Before I proceed, PEC versus IEC 80. Maybe a lot of people will ask where are the two going to converge or how is the two related with each other. PEC focuses on how we execute the earthing system, bonding, where it's going to be connected, how it's going to be connected. But IEEE 80 is the calculational component where you have to understand, we have to determine the performance of the earthing system in respect to during a fault conditions. Kasi alam natin, during a fault conditions, in theory, your earth is on a 0 volts level. But in an faulted condition, that 0 volt is not 0. So what happens if during a faulted conditions, how does the earthing system perform? That's IEEE 80. So they are complementing each other. In fact, it's actually a susunod na kabanata ng ng PEC. Nagawa mo nga yung earthing mo, nasunod mo lahat yung PEC requirements mo, but you still have to determine what happens if there is a fault in the system. That's IEEE 80. So yun yung pinag-usapan sa IEEE 80. Kaya medyo, sabi nga kanina, nakakalimutan. Hindi masyadong na-emphasize importante ng earthing. This is where we must emphasize. Ang sabi ko nga po minsan, madalas kong tinatanong, kung nasunod na ba natin lahat ng PEC requirements, bonding and everything, are we confident that we are actually had done a good, correctly designed earthing system? The strict answer is no. You have to perform IEEE 80 so that you can answer that question. Hopefully, we will be able to cover that topic tonight. Okay, review and validate earthing practices with special reference to safety and develop criteria for a safe design. Medyo important, medyo emphasize yung mga safety issues. Because at the end of the day, correct earthing, and the proper bonding and proper execution of earthing design redounds to safe practice, equal to safe practices in the power system. Pag hindi mo na-execute yan, then safety is already compromised. So, ito yung mga tawag ko dito, important recognitions or realizations that we must be able to emphasize tonight. Okay, so I would like to proceed. What are the factors that drive earthing design? First, we must review what are the conditions of danger. No? During a typical fault conditions, the flow of current to earth will produce a potential gradient within and around substation pa sinasabi ko doon. I maybe have to change that into a power system. Kasi wherever you are in the whole power system, ganun din ang nangyayari. Whether you're on a substation or within an ordinary power system environment, during a fault condition, it produces potential gradients or potential differences in the different parts of the system. Depende kung gaano kaganda ang earthing system mo. Okay. Then earthing design must address the circumstances that make electric shocks accidents possible as follows. Earthing design must address the circumstances that make electric shock accidents possible as follows. Ano atong mga to? Relative or high fault current ground in relation to the area of ground system that is resistance to remote earth. Number 2, soil resistivity and distribution of ground currents such that high potential gradients may occur at points of the Earth's surface. And of course, the presence of individual at such point, time and position that the body is bridging 2 points of high potential difference. And absence of sufficient contact resistance or other series resistance to limit current through the body to a safe value under above circumstances. The long and the short of this is kung ikaw nandun sa sistema na nagkaroon ng fault and you happen to be within a certain 2 points of that grid, then there is a possibility that you are subjected to the potential difference, the potential gradient between the 2 points. And this is where the whole IEEE 80 is focused on. Ano yun? What are the safe limits of that potential difference? And there are 2 points. We call it, I'm jumping the presentation, but just to start and make a certain, to lay down the direction of the nice presentation is, it's either between your feet, yung paa mo, which is what we call a step potential, or between your feet or your hand. Halimbawa, nakasandal ka sa isang bagay, yung concrete nga lang sa pag medyo masama ang earthing mo, mararamdaman mo eh. Pag masama yung fault eh. Mararamdaman mo between your hand and your feet. Kung medyo masama yung location mo at masama yung fault condition, or all the parameters of a faulted condition exists. And that is what IEEE is all about. Being able to determine, number one, what is the maximum that the body could tolerate between this feet and the touch, and what are the safe levels that has to be determined to be able to be able for a certain body, female or male, to be able to survive. Kasi pag hindi mo na kaya nun, death will happen. Sigurado. And this is, okay, meron mga isa pala, duration of the fault and body contact. And these are what we call now establishing the design parameters, duration of fault. And hence, the flow of current throughout the human body for a sufficient time to cause harm at the given current intensity. Medyo critical yung duration of fault. So these are the conditions of danger. And the tolerable body current limit is the most common physiological effect of electric current in the body in order of increasing magnitude. Ibig sabihin, ano yung kaya natin ng katawan ng tao? Meron tayong nakakayanan dyan. But then, what are these? Ang sabi nga nila, the threshold of perception. Muscular. Yung threshold of perception, medyo nahawakan mo, nakikiliti ka na, naramdaman mo. Threshold of perception. Muscular contraction. Medyo nanigas yung kamay mo. Mapapansin mo yan eh, kung tinawaan ka. Then finally, the second one, unconsciousness. Pag mas matagal ka ng konti at masama yung hawak mo, you end up unconscious. Then the fourth one will be fibrillation of the heart. Anong ibig sabihin yan? Titigil na yung puso mo. Kasi nga, meron ng effect yung the current through the body. And finally, of course, respiratory nerve blockage. Medyo hindi ka na makahinga. And of course, after that, burning, sunog ka na. And that's normally what you see when electrocution happens, yung mga ordinary na aksidente, lalo na yung mga lineman. Sunog talaga yan. At if you notice, pangkaraniwan yun, butas yung paa o butas yung kamay. Yun yung mga manifestation doon dumaan yung kuryente. And these are the things that the effect of fault or current through the body. Now, factors, body current limit, 1 milliamp threshold. Threshold of perception na yan. Mararamdaman mo, 1 milliamp. Current magnitude at which a person is just able to detect a slight tingling sensation caused by the passing of current. Yan, nakakakiliti ang sabi nga nila. 1 to 6 milliamps. We're talking of milliamps. Let go. Nabibitawan mo ba yan? Yun yung automatic na bibitawan mo. Let go current, unpleasant to sustain, but generally do not impair the ability of a person holding an energized object to control his muscles and release it. Kaya mo pang bitawan. Pero yung susunod na yan, na 9 to 25 milliamps, painful and difficult or impossible to release. The energized objects grasped by the hand. Higher currents, muscular contractions could make breathing difficult. Di mo na kaya. Talagang maninigas na yung muscles mo or hindi ka na makakagalaw. Of course, the susunod yan, 60 to 100 milliamps, ventricular fibrillation, stoppage of the heart or inhibition of respiration might occur and cause injury or death. That's something that you would like not to happen or you don't want to happen. So yun. Tolerable body current limits. Medyo 1, 2, 3, 4. 1, 2, 3. Ayaw mong pumunta doon sa number 4 or number 5, number 4. Number 3 and number 4. Medyo masakit and delikado na yung pang-apat. Okay, so kanina nabanggit ni Sir Eric, material resistivity. Bakit parati natin pinag-uusapan yung surface material resistivity? Ang tanong ko karamihan pag nire-lecture ko ito is bakit kailangan natin yung bato sa substation or gravel field sa mga electrical installations? Bakit? Pangkaraniwan na sagot sa akin dahil daw sa damo eh. Ah, to prevent pagtubo ng damo. Sabi ko nga, well, it is correct. Tama nga naman. But the actual reason why we need the gravel is on the surface of an electrical installation, especially substation, is to be able to introduce a resistance or a high resistance material between yung tao at saka yung grounding systems na nasa ilalim. Remember, binaon natin yung grounding wire sa ilalim. And there is a certain limit kung bakit gaano kalalim na naman to. Sabi ni Sir Eric kanina, ilang metro? 8 feet yung grounding rod mo, pababa. Pero yung earthing wire, ano yung minimum na lalim ng wire sa ilalim, sa rupa? 2 feet or about 0.6 meters. Minimum yun, minimum. There are others who require at 1 meter, yes, but then i-check ninyo, ito pang additional note ko doon, i-check nyo yung soil resistivity doon sa lupa. Itong surface material resistivity must be recognized as a different material from the earth resistivity doon kung saan nakabaon yung earthing natin, yung wires natin. They're two different material. So, anong kinalaman? What is the relationship between those two types of materials? The soil resistivity, we would like to have it at a very low value because it conducts better the ground to dissipate within the ground kung mababa ang resistivity ng lupa. Pag mataas yan, it acts as a resistance for the flow of current to dissipate into the ground. Yung surface material, yan yung bato sa ibabaw. So, ang recognition dapat ito magkaiba yung dalawa. So, you would like to have a surface layer sa taas na mataas naman ang resistivity para it acts as an additional resistance to your body resistance when you get in, kung nagkamali kang nakahawak or nakaapak doon sa area of a faulted, during a fault conditions. So, very important yung bato na yan. Hindi dahil sa damo, but rather to add additional resistance between the body and the point of dissipation nasa lupa sa baba. So yun yung additional resistance na kailangan mo. Then the current through the body will be lowered considerably with the addition of the surface material because of the greater contact resistance between the earth, yung sa baba, yung earth na pinag-usapan natin yung sa ilalim ng bato at saka yung katawan ng tao. So yun yun. Kailangan na meron kang additional resistance doon. Kaya nga yung mga iba, anong gamit ng bato? Dahil daw sa damo. Sabi ko, hindi. Dahil sa earthing yan. Safety is a safety issue. Yeah, high resistivity. Magdagdag ka ng high resistant material para safer yung substation or yung power system installation mo. Okay, so the reduction depends on the relative values of the soil and the surface material resistivities and on the thickness on the surface material. Yun sinasabi ko. The reduction depends on the relative values of the soil sa ilalim at saka yung bato sa ibabaw. And of course, the thickness of the bato. Again, what is the minimum thickness? Sabi nila 2 inches. No, hindi dapat. Minimum ideally is 150 mm. Pero 100 mm pwede na rin. Pwede na rin. But if you experience a high resistivity on the ground, lalo na kung yung mga fill area, yung backfill, dagdagan mo yung bato kasi masyadong mataas yung resistance sa ilalim eh. Baka mamaya, mas mahirap mag-dissipate, mas mataas ang potential sa ibabaw. So the more bato-bato you should put between you and that particular ground and sa ilalim. So although codes and standards say it should be at least about 100 mm, but I always specify 150 para masigurado. Okay. Drivers, design drivers. Ang pinakamalaking driver dyan is symmetrical fault current. what it is. So that's why mas talas kong sabihin, when you do IEEE 80, dapat marunong ka rin mag-short circuit. Baka mamaya hindi mo rin masolve to pag hindi ka marunong mag-short circuit. Because what is crucial here is what is the zero sequence current that is passing to the ground. Yun lang naman ang pinag-uusapan dyan. Paano ma-determine yan? Well, of course, it can be done through a symmetrical method, or there are a few things that can short this calculation. But remains that what is the driver, the most important driver of everything design is to understand what is the symmetrical earth fault current that is present or might be present within the system. It is represents the RMS value of the symmetrical component in the first half cycle of a current wave that develops after the instant of fault at time zero. And for phase to ground faults is 3 times the zero sequence current. And I don't know, during my lectures, kuminsan, ano daw nga pala yung I.O. Hindi madaling calculated ng I.O. eh. Unless you know the zero sequence reactances your system, mahirapan ka. So how do you determine your I.O.? I don't know kung dito kasi, teka muna. There's always a question I ask. What is the maximum line to ground fault current when your system happens on a fault? There's always that approximate value. What is the maximum earth fault current that will be present in a system? And a maximum fault, what they call an ideal line to ground fault, what they call a maximum offset, it's always equal to your 3-phase volume of fault current. Pareho yan. The maximum theoretical line to ground fault is always equal. In fact, more sometimes than your 3-phase fault. So that's why, kung hindi mo alam, just use your 3-phase fault current as a calculational basis. Kaya nga sabi ko dito yung symmetrical earth fault current ng Earth is equal to your symmetrical fault current, 3IO. It's a long process of calculational what they call this process doon sa symmetrical components. When you maximum offset perfect fault, one of the phase voltages equals the phase-to-phase voltage. So yun, maximum offset, maximum fault current na rin nakalabas nun. So kung gagamitin mo yan, you're probably around safer than you should be. Okay, factors that drive again, tolerable earth fault current inversely related to the square root of exposure on time. So ibig sabihin, meron ng time issue. That's why the exposure time or tolerable fault current is inversely related to the square root of the exposure time. Ibig sabihin, how long are you going to be exposed? And that determines how fast your protection devices will work. So exposure equals how fast your protection devices will work. That's why very crucial yung time delay ng earth fault protection natin. Now, how do you determine that? And how do you set that is one crucial factor when you do also your protection settings. Ano yung mga normal na tinitignan or basis to set your trip point or the trip current or the trip time, or we call now time to clear on the fault. What is the time to clear of the fault? So yun yan. Medyo crucial yan. If you do calculational IEEE 80, malalaman mo dyan na yung time to clear is one of the most important factors. Napakalaking impact niya. Okay, the allowed current value must be based on clearing time of the primary protective devices. Kung dalawa yung level of protection mo, then you have to look at the primary and the secondary or your backup protective devices. Dalawa yan. Pag nag-fail yung isa, dapat may isa. What are those clearing times? Kailangan wag lumagpas sa isang value. Otherwise, makakapatay ka ng tao. Now, primary protection is possible due to primary protection clearing time is possible due to low combined probability. Ibig sabihin, baka yung isa na lang i-consider mo kasi the probability of two failing mas mababa naman. Lalo na simpler systems. Pero on AHV and 69 kV and above or 36 kV and above, dinadoble na namin yan. Meron ka ng backup protection. And what are these? Just to quickly, what is the primary protection and the secondary protection sa earth fault clearing? Tinatanong ko kuminsan, what's the difference between the 5051N and the 50G? Sa mga sistema natin. Those are the two primary and secondary protection. The 51N is what you call a residually connected protection, earth fault protection, ground fault protection. And the 50G is a zero sequence protection. Magkaiba yan. Magkaibang city ang gagamitin mo dyan, although magkaibang relay din ang gagamitin mo. So that must be a very clear recognition between when you do protections also. And backup protection clearing time is more conservative because of greater safety margin. Ibig sabihin, greater safety margin, mas mabilis na siya. So yung 50G, anong setting niya? Halos instantaneous. Pero mas mataas ng value niya ng konti as against yung 51N. Pero yung 51N, a certain time before the what you call this, the 50G. Mas mataas ang threshold ng 50G, pero mas mabilis yung time to clear niya. So these are the things when you do coordination and all that. Although we're talking about earthing systems, but how do you achieve that? Nandun sa protection system mo achieve yan. So kailangan idikta mo. Bilang ikaw designer, idikta mo yung settings doon sa design. Okay? Ang tanong ko ngayon, meron kong isang tanong. Bakit crucial yung time to clear? As we discussed kanina, at a certain point of time, pag hindi mo na bitawan yung fault, nandun ka sa sitwasyon ng earth fault, sa loob ka ng substation na faulted, it might be that the time to clear is too long, that it may affect yung puso mo. Kasi nadaan na yung current sa'yo at may impact to your heart. So, pag hindi mo naunahan yon, there's a possibility that your heart may stop. So, kaya nga tanong ko kanina, ano yung maximum setting natin pag set ng mga earth fault relays? Meron yan. Kung bakit? Nung araw, sinasabi lang ng aking mentor, the Meralcoman Binong Ocampo. I don't know if you heard this guy, a very old guy na guro sa relaying. Sabi sa akin, huwag mong iset yan more than 0.25. Bakit? May rason kung bakit. Hindi ko alam, hindi ko naintindihan yan. Until I read this or I made this presentation. Because at 0.3 seconds, your heart will stop. At 0.3 seconds, your heart will stop. So, ang time to clear mo dapat is less than 0.3 seconds. Hindi ko alam kung bakit, but this is what the reason na kung bakit. Kasi mamamatay na yung tao pag hindi mo trinip yung system mo before 0.3 seconds. So, it's all down to safety pa rin yan. It's all down to safety. That's the reason why. Kasi at 0.3 seconds daw, the research provides, medical statement ito. Research provides evidence that the human heart becomes increasingly susceptible to ventricular fibrillation. Ibig sabihin, titigil na yung puso mo when the time of exposure to current is approaching the heartbeat period. But the danger is much smaller if the time of exposure to current is in the region of 0.06 seconds or roughly 0.06 to 0.3 seconds. Pero 0.3 is the limit. Definitely sa 0.3, there's something wrong already. Makamamatay ka na. So, it's about 3.6 cycles to 18 cycles. Kaya kung minsan, sa low voltage system, medyo problema yung 3.6 cycles. Kasi alam natin, ang mga magnetic breakers or molded case breakers are slower than 3.6 seconds. Hindi niya kaya yan. Maybe about 5-8 cycles pa nga ang magnetic breakers natin ngayon. So, but then, ang mo naman, ang tawag ko dyan is, ang recourse action mo is mababa lang yung fault current mo naman doon sa LV systems. Hindi naman umaabot ng 100 or 40K yan eh. Nasa 10 to 14 lang yan. So, if you notice, when you do your calculations, especially in the HV system, nasa 20-40 kiloamps mga ginagamit nating fault values dyan. So, bottom line, kailangan natin kaya nga doon nang gagaling yung 0.2 to 0.25 seconds delay natin sa earth fault protection. Kahit saan mo ilagay yan, it should be faster than 0.25. Okay. System XR ratio, that's the rate of decay between from the asymmetrical value to the symmetrical value. It is a factor, but it's not so much. So wag natin pag-usapan muna. Medyo matagal-tagal yan. But alam natin na ang system XR dictates the decay of the asymmetry of your fault current. That dictates that. Kung malayo ka sa power source, then the faster it decays. Pag malapit ka sa power source, then the slower it decays. So pag nasa design ka ng mga grid connection facilities, medyo ingatan mo yung XR. Pag malayo ka, nasa node ka, mga malayo sa power plant, medyo pabayaan mo na lang muna. Mataas na yung XR ratio mo dyan. Okay. So mabilis mag-decay, ibig sabihin. Levels of engineering calculation. Itong dalawa na ito, medyo ine-emphasize ko masyado. Technical specs or limiting values. Ano yan? System performance, equipment selection for regulatory compliance sa procurement. Yun yung first level of calculation mo. Hindi natin na-realize na when we design, dalawa yung calculation na gagawin mo. Yung tawag ko doon yung una is level or system performance or the limiting values. Hanggang saan yung design mo aabot? Hanggang saan yung system mo magpe-perform within the requirements that you want. So that's your performance requirements. That's your first calculation. That's your specs. So when you write the specs, that's the calculation. But when you do your setting, protection, control, instrumentation setting, kailangan mo nang i-calculate yung values mo. For example, sa grid rate, as a grid connection natin, kung minsan 34.5, nandun ka sa dulo ng 5 kilometers away from the Meralco substation, ano yung fault duty mo dun sa PCC mo o point of common coupling mo? Di mo alam. Only Meralco will be able to tell you that. The more so when you go to 69 kV, you are about 10 kilometers or 5 kilometers from an NGCP substation, anong fault duty dito? So kung minsan, yun ang dilemma ng engineer. So ang gagawin mo, anong calculation gagawin mo dyan? Dalawa yung sinasuggest ko dyan. Either you go to NGCP or to the utility and ask for the system fault duty at the point of connection, or you do your calculation based on unlimited bus or infinite bus system. Because if you do an infinite bus calculation, hindi ka magkakamali dyan. You're always be on the higher side to a certain degree. Pero if you do a calculation, if you include the system fault, which is in terms of when you do the reactance diagram, maliit lang naman yun ang impact niya doon sa substation. But then, in this calculational, marami kasi may mga hindi nila na-realize na the short circuit calculation is so simple. Napakadali yan. Ang problema nila kasi, hindi nila na-realize na if you calculate based on infinite bus, you only have what parameter to limit the fault into your system. Yan ang pagkarino tinatanong ko What is the limit? Alam na ni Carol. Pang-ilang wag mo sagutin. What is the limiting value of the fault at the secondary transformer if you are connected to the grid? So, maraming hindi nakaka-realize na the only limiting value is the transformer impedance. The transformer impedance limit the short circuit into your secondary system. It's the only factor that will limit you. Plus, of course, the limitation of the grid fault conditions mo. Dalawang resist impedance yun na makaseries kung sali. Kung igagawin mo yung reactance diagram niya. So, the point is, we're here in terms of the engineering calculations. When you do your calculations of fault, kasi crucial yung fault current gamitin mo na lang infinite bus so that it's the maximum fault current that you can expect at the secondary transformer. Now, may mga nagtatanong, solar ako, pero paakyat. Ano yung considered na earth fault conditions ko? Nakakita ako ng isang professional engineer's work, PEE, Manong Conrad. PEE, bro. Hindi niya malaman kung anong short circuit duty gagamitin niya doon sa primary ng solar substation niya na grid connection ng substation niya. Remember that you have to know, kasi nasa calculation na tayo, no? You have to know exactly where you are in the grid para makalculate mo yan. Now, if you are calculating the fault current duties at the primary of a substation, whether it is generation or transmission, generation ka or nasa load end ka, sending end or receiving end ka, you have to understand where you are. Kailangan alam mo kung nasan ka. Dahil kung nasa generation side ka, more likely than not, that generation capacity is less than the grid capacity. So what is the fault duty that prevails into your system if the grid connection facility is connected to the your high voltage system is connected to the grid? My advice is hanapin mo muna yung grid fault duties na nandun. Because kahit generation ka, magkaroon ka ng fault sa generation side or dun sa primary side, it's still the fault duty of the grid that will dictate the whole system. Kasi maliit yung planta mo eh. Sunugin mo na yung planta mo, hindi pa rin niya kayang mas malaki kaysa yung grid capacity mo, especially for Luzon. And Luzon is what? 12 gigawatts. What's the fault duty depending on the voltage where you are? So if you are at the 115 kV, you're more likely at about 8,000 kVA. If you are at 69 kV, you're probably limited to 1,000 to 1,005 MVA. MVA. But if you are at 15 kV, you're probably limited to 500 MVA maximum fault duties. Pag mas mataas dyan, hindi po pwede dahil you need to be able to decide whether you go 15, 17, or go to 34 or go to 69 kV. Why? Wala ka na mabibiling equipment na maka-comply doon sa requirement ng fault duties. Okay, so pagdating sa levels of calculation, medyo everything is dictated by a lot of what we should do pagdating sa short circuit. Kailangan ma-realize natin na related yon. Okay, ito yung tinatawag kong bakit pinag-uusapan ang earthing AEEE. Yung limits, the performance parameters has to be defined by, yung tawag natin mesh voltage, must be less than the maximum tolerable voltage that a human body can tolerate. And your earth grid design is safe. Pag mas mababa yung calculated mesh voltage mo, kasi you have to calculate the mesh voltage during a fault. And you have to compare that with the maximum tolerable touch voltage that can be tolerated by the body. Then the second one is step voltage criteria. The step voltage criteria must be less than the maximum tolerable step voltage that is present during the fault. So then, of course, your design is okay. If not, magre-recalculate ka. Mag-iterate ka sa design. And what are these factors that will have to be considered? Ito yun. I'm just summarizing the time duration of fault or the time clearing or fault clearing time, maximum symmetrical fault value. These are listed in accordance to, tawag ko dyan, yung impact niya, sa importance na niya. Kasi nga, when I've been doing a lot of this, sinisimulate ko, ano nang pinakamalaking pwede kong batakin para galawin. Okay, cell resistivity and the depth of earth conductor, surface layer resistivity and thickness, then system XR, then finally required earth resistance. Ibig sabihin, yung required resistance natin, yan yung hinahanap ng PEC. Yan yung pinapakalculate ng PEC. Pero tignan mo sa hierarchy ng kanyang driver, 1, 2, 3, 4, 5. Pang-anim lang siya doon sa earthing calculation, IEEE. Mas mataas pa nga yung importansya ng XR yan kaysa doon sa you can have sa code, ito pa ang isang nakakapagtaka. The code, the PEC requires allows 25 ohms. But in practice, we are not doing that. We are limiting it to 5 on substations and maybe even 3 ohms for big substations and power plants. Sa mga building siguro po pwede 20, but I don't think I will allow that. 20 mataas. But nevertheless, it's not really that much. Hindi masyadong issue. Kaya naman pala the code is not really that strict. Kasi hindi masyadong issue pagdating sa earthing. I mean, sa AEEE. Okay, so the area covered by the earth grid. Yan. Gaano kalaki yung area? Ano din yan? It defines how much wire and how much ground rods that you're going to put on the ground. Kasi yung covered area mo, medyo kinakalculate yan. Okay, so that's it. I hope that I was able to give you an overview of how we are going to be impacted by an improperly designed system. And hopefully we learned something tonight. Thank you.
Thank you, Chair Adele. Um, for the online participants, just send in your question and later after the talk of the four panelists, i-discuss po natin siya isa-isa. Okay? And for all those present here and all those who joined the online participants, congratulations to all of you, to all of us in advance kasi talagang napakaganda ng topic natin ngayon. My only regret is that we should have done this half day or whole day even. Kasi bibihira kasing mapagsama-sama mo yung chairman ng 4 na committees ng IIE. Experts, and they are sharing their expertise, knowledge, and experience to us. Decades yun na dinevelop nila tapos isi-share lang nila sa atin, pinaghirapan nila yan. So again, congratulations to all the participants online and face-to-face. And also, this Tech Talk would not be possible without the sponsorship of IIEE, Electrical Safety Committee, in cooperation with the Metro West chapter. Also, we have to thank our sponsors who made this possible: Duraflex Wires and Cables, Philplex Wires and Cables, and Hypertech Wires and Cables. Napakagandang brands. So, sana ipatronize natin siya. Total, 3 naman sila. Yung Phase A, kunin nyo kay Duraflex, ay kay American Wire. Yung Phase B kay Philplex, and then yung Phase P kay Hypertech. Yung grounding, bahala na kayo. Anyway, kidding aside. So moving on forward, from one great speaker to another great speaker, who will discuss grounding systems and international standards, IEC and product standards, with global perspective on grounding standards, IAC grounding standards, how do they compare to the PEC and NEC, product standards and safety, standards for grounding components, example, graphia, e.g. rods, clamps, bonding, conductors, ensuring product safety through certifications and compliance with IEC, emerging trends in grounding standards, how product standards are evolving to address modern electrical safety concerns. Ladies and gentlemen, may I present the chairman of the Standards Committee, Engineer Conrad Binondo, PE.
Good evening to everyone. Yung topic na nasabi, ang haba niyan, we need probably a week, for this topic. So I really appreciate my colleagues here, yung mga kapartners natin dito, for the presentations. But here we will try to complement each other, no? Kasi napakaganda nung topic na ito, grounding, which is almost sa audit na mga ginagawa ko, no, sa mga actually in buildings and some substations. And ang weakness ng mga installation na ito, 70% to 80% is mostly related to the implementation of the grounding tsaka yung bonding. Kanina napag-usapan dito sa topic ni Sir Adel, there are two variables that relates to the protection of a person. Kasi ang pinag-uusapan natin dito, why we ground, why we bond, the installation. Isa lang the most important thing here is the protection of the person against electric shock. So in IEC, kasi sa IEC level, there are two major horizontal basic tawag dito standards. Yung IEC 61140, ito yung ginagamit sa lahat ng installation, whether it's low voltage or a high voltage. Sa IEC kasi there are only two categories of voltage. That is the low voltage and the high voltage. So magkaiba yung standards natin sa IEC ng low voltage saka yung sa high voltage. Now, meron pang isang standard which is the TS 60479. Ito yung the protection of person, yung magnitude of current passing through a human body, yung kanina pinag-usapan, which is related to two factors. Number one is you must control the magnitude of current. Alam mo yung magnitude of current. Kanina sinabi ni Sir Adel, yung mga various level of magnitude of current, pupunta ka sa hanggang sa mapunta ka sa sa FB, fibrillation, ganon. Then meron yung threshold, yung let go value. So meron yung tingling. So those are part of the standards sa 60479, in which yung IEEE 80, yun ang reference niya, yung IEC standard. So probably itong mga standards na ito, if we have probably ito siguro susunod, ano, but because these two standards are not intended for katulad natin yung mga electrical practitioners, no, these are reference for technical committees when they create ano mga requirements, mga application guides, no. So ito yung ginagamit. So ano yun, anong standard yung gumamit noon, yung dalawang reference na sinabi ko is actually the 60364 standards. Ito yung sa low voltage. Yeah. Ito yung low voltage installation and protection against electric shock, wherein I'm a member of the IEC TC64, no? Sa level na yan, then siguro ang pag-uusapan natin, because the protection against electric shock is a big project, no? Very wide ang scope niyan. Kung kanina nasasabi ni Sir Aldel na 300 milliseconds, well, you can find that in 60479. Nandun yung sa standard na ginawa ng 60364, basing on this 6479 is actually 200 milliseconds, no? Kaya ngayon, 0.2. So 300 safe ka na. Pero you know, sa curve na yan sa 60479 protection against electric shock, there are 2 points nga. Yung merong time tsaka yung sa magnitude ng current, wherein ito yung ginagamit ng lahat ng manufacturers, ano, sa low voltage. The product standards, ginagamit nila ito so that it will meet the requirements of the standard. Ngayon sa mga high voltage, ganun din ang ginagamit nila. For example, the protection relay must meet the requirements, no, of the standard na ang tao subjected, no, to even to a higher magnitude of current. Halimbawa, sabi natin 10 milliamperes 4 to 6, then after that pupunta tayo ng 20, pupunta tayo ng 50. Anong gagawin natin doon? Then the time element to disconnect, no, the supply where the person have touched the live part, yun ang protection niya. So basically it's all protection against electric shock, whether in low voltage, in high voltage. Iisa lang yung fundamental principles diyan. That ang fundamental principle is that the live accessible parts should not be accessible. So this is through barriers, yung mga barriers natin. Kung maging live part niya, it should not be dangerous. And these are the basic fundamental rules of protection against electric shock, no? Yan, nakadefine lahat yan sa IEC. Pero ang subject ko ngayon is about grounding and banding, but for here, kukomplement ko lang kasi yon. Then let me direct you now to the 60364 standards, ano, when it comes to earthing system. So ganito yun, ano, there are 2 parts, pero napakahaba nito pag tinakel natin, ano, because in IEC meron tinatawag na system earthing, and there's another one called the installation arrangement, yung earthing arrangement sa installation. So let me bring you to the slides. Okay? At tayo nga ako para baka mabali yung leg ko. Okay, let me So, ano ba yan? Sige, kuha na lang. Hindi, okay na lang. Ganun mo na lang. So, oo. Saan ba? Down? Yung papaganon. So this is the IEC earthing systems. Dati nile-lecture ko, tsaka yung earthing arrangement, ano? But the thing is that this is a very big topic. Ang mahaba, dalawang standard eh. Pero let's focus on the fundamental principles, yung requirements ng code, ng standards is the IEC earthing system. Sa atin naman, ano yung grounding system natin, di ba? When you talk about the PEC, we have what we call the grounding system. Sa IEC is the IET earthing systems. Okay? Ay, ayaw. Saan ba? Dito? Dito? Yan, ayaw. Yan. So of course, IEC, this is IEC-based presentation. Kung titignan natin worldwide, so we have a concept, ano? Ano yung coverage ng IEC? You can see the green. So IEC national committees are around the world. Philippines is part of the full member of IEC. Then meron tong associate members and 45 affiliates. Kaya lang ito pinapakita ko probably because itong topic natin all around the world ginagamit ito eh. So ito yung gumagamit ng IEC. Now let's go to the next slide. IEC worldwide, you could see IEC, the influence, ano? Yung sa blue. Okay? Ang UL and FPA, of course, nandun sa USA. Yun ang common na standards na ginagamit. Then we have the mixture. So makita nyo, Philippines mix, di ba? IEC, UL, and FPA. Ang PEC natin is based on FPA. Okay, and UL, of course, the product standards. Then IEC, meron tayong mga products na ginagamit based on. So yun ang tinatawag na mix. Ano? Of course, Canadian is in Canada. So this is the standards. Numerous na pinresent ko na to, no? This is similar to the PEC. Kaya lang, doon tayo sa point ng low voltage. No? When it comes to the Philippine Electrical Code, this is the low voltage standards, electrical installations. No? So, what is this? Ayan. Now this standard has been adopted, no, sa noong 2020. We have this reference. No? You can purchase this in the Bureau of Philippine Standards. So we could use this as a reference. Kaya lang meron kaming country notes na tinatawag that the use of this standard shall be in conjunction with the latest edition of the Philippine Electrical Code. You know? So PRC, of course, the PEC is a part of the rules and regulations governing the practice of electrical engineering, referral code ng National Building Code. So ito lang disclaimer. Baka mamaya sasabihin nyo, ginamit namin na nagkaroon ng problema sa installation. You have to take note, should there be any difference in interpretation on the provision and requirements of this standard and the Philippine Electric Code Part 1, the provisions of the Philippine Electrical Code shall be maintained. So minimum requirements ang Philippine Electrical Code. No? This is what it means. Now, what is this? IEC 60364. It has 35 documents. So merong 21 sections are corresponding to special locations. Ito yung mga part 7, ano, wherein these special sections can modify the requirements, ano, yung fundamental principles, yung 1, 4, and 5, and 6, ganon. So 6 main parts: fundamental principles, part 1, part 4 is protection for safety, selection and erection of electrical equipment, part 6 is verification and test, ito yung inspection, special locations, then part 8 functional aspects, no? So pag-uusapan natin yung part 1 kasi nandito yung pinag-uusapan natin ngayon, no? What is the importance of this? Ito yung reference eh. When it comes to the IEC earthing systems, no? Wala silang tinatawag na grounded and ungrounded system. Wala kang makikitang ganon na terminology when you go to the IEC, no? Standards. So meron yan, TNTT, and IT. Yan ang ginagamit. Ano? So this only covers 1,000 volts AC or 1,500 volts DC. So kung makikita nyo, fundamental principles assessment of general characteristic give the rules for the design, erection, and verification of electrical installations. Tingnan nyo, the rules are intended to provide for the safety of persons, no, and property, livestock nakasama, and property against danger, no, which may arise in the reasonable use of electrical installation to provide for the proper functioning of those installation. Whether high voltage or low voltage, ang lahat ng access natin dyan, when we enter a substation, no, for example, yung effect kasi ng magnitude and the time that is required in protection against electric shock, presence lahat yun, whether the installation is low voltage or what we call a high voltage, no? Ayan yung number 1 na hazard in electrical is shock currents. Ito yung pinag-uusapan natin ngayon to protect the person, ano? Okay? So marami pa yan. So application, similar to the PEC, ito yung coverage, ano? You have the residential premises, public, industrial premises, and so on and so forth, no? Okay? Yan yung application niya. Then yung part 4 of this standard is the protection against electric shock, protection against thermal effects, protection against overcurrent, protection against voltage disturbance and electromagnetic disturbances. So, napaka-importante yung system earthing, ano? Tsaka yung earthing arrangement sa installation. When you want to protect, to meet this protection, kailangan tama yung installation mo. Ano yung common dito? It's the earthing system. Tsaka yung protective, yung tawag yung bonding, ano, ng mga equipment. Okay? Now, sa part 5, meron dito yung earthing arrangement and protective conductors, dito pumapasok ang similarity ng PEC 1250. Okay? Very specific yan. Magsasama itong dalawa na to at saka yung sa part 1, yung system earthing. And is this part 554, these are the details. Nandyan yung details, how would you connect from the transformer papunta doon sa main distribution board, papunta doon sa mga load mo, hanggang the farthest load, no? Yung protective, yung arrangement para walang mixture. Otherwise, you will have a problem in your installation. So of course, ito napakahalaga, you have to verify your installation. Na-meet mo na yung mga requirements na yon, na-implement mo na-select mo na yung mga devices, then you have to verify the installation. This is during the construction, saka yung post, verification. Then this is standard, nandyan lahat ng forms na gagamitin mo, the requirements on how you conduct the verification and inspection, pati na rin yung testing. Then part 8 is the functional aspect, energy efficiency, yung installation mo sa prosumers. These are a lot of topics to discuss. Another subject yan. Then we have the part 7. Itong part 7, nakakakuha nito eh. This one, it will modify the requirements, doon sa naunang mga parts. Parang yung sa atin din, merong special requirements, special places, special conditions. So kasi makakaiba eh. Iba-iba yung treatment nila when it comes to earthing. Of course, merong part 1 na susundin yan. Common sa lahat yan. Pero how would you do the connection? Yun ang pinagkakaiba nila. Yung mga parts na yan. So merong specific na requirements which is not defined dun sa general rules. Ganon. Parang yung sa PEC natin, merong mga ganyan. Sa swimming pool, sa bathroom, merong specific requirements on how to band. The swimming pool, how to band yung tawag dito, potential banding ng swimming pool. Okay. Then ito yung overview. I want you to look at this. Ito yung 60364 overview and structure, So they are all related to each other. So ang pag-uusapan natin ngayon yung earthing yung earthing systems. Okay, sa IEC, you define the current carrying conductors in AC circuits. So ganito yun, meron tayong single phase, 2-wire, there is phase angle 0, single phase 3-wire. So titingnan nyo anong similarity niyan sa mga distributions natin, Merong phase angle, yung split phase, line 1 and then meron yung iba dito. Then you have the Y without the neutral, and we have the delta. Then we have the 3-phase 4-wire, yung mostly ginagamit natin. So yan yung current carrying conductor. So ano yung i-ground natin dyan? Ano yung i-earth natin? Of course, tingnan natin yung PEC natin, kasi may similarity yan eh. Ayan. Sa PEC 2.50.27, ito yung conductors to be grounded, Pag gusto mong i-ground. Single phase 2-wire, one of this, ito yung line to ground na tinatawag. Very common yan, line to ground sa mga province, yung mga installations natin doon. Then single phase 3-wire, yung neutral, yung split phase yan, yung nasa gitna. Yung mga poste dyan sa Meralco. So you could see, line 1, line X1, tapos yung sa middle, then yung X3, X1, X2, X3. Naka-ground yung isa. So these are the split phase. Then of course, you have the multi-phase system, having one wire to all phases. Okay, meron siyang neutral conductor. Normally, ito gina-ground yung neutral conductor. So multi-phase system, when one phase is grounded, yung delta, corner grounded, Phase, one phase, live yun. So i-ground mo yung isa, open the corner grounded yun. Then multi-phase system in which one phase is used as in 2, pero the neutral conductor, gagawing neutral conductor yung isa. Okay? Then of course, sa DC circuits, we have also this type of arrangement. Lalo na pag nasa PV kayo, sa mga batteries, these are the requirements. Now, ito na ngayon. Para hindi tayo magkalituhan dito. This is very important for everyone. Yung mga nasa online. Sabi ko kanina, in IEC, di nila sinasabi yung grounded or ungrounded system. Pag sinabi nila na TN, alam na ng mga practitioners yan doon. Yung implementation. Ano yung gagamitin mo? TN, tapos na. Kasi sa atin, sorry to say, lahat ng specification sa project, minsan kung generally sa drawing, sa mga shop drawings, makikita natin you should follow the requirements, of the Philippine Electrical Code sa installation mo. Very general. So, yun, mayroon mga nakalagay ng mga specific sometimes, yung size of conductors, everything. Pero sa kanila dito, the moment you specify this earthing system, ganito, it's well understood na. Kapag kayo sa ibang bansa, di ba? Sa Europe, pag nasa Germany, nasa France, or whichever, pag nag-usap sila, it's very easy for them to understand. For those countries na inadapt nila yung IEC, no? Standards when it comes to the earthing system. So ganito, titignan nyo yung first letter. Ano yung first letter na ito? There is T, Then merong I. Ito yung relationship of the power system to the earth. Ano yung power system? Tingnan natin para mas madaling maintindihan. This is the source, yung transformer, Ito yung transformer natin sa low voltage, may secondary. So, ayan yung nakalagay dyan, relationship of the power system. Kapag T siya, direct connection of one point to the earth. Okay? To the earth yan. Connect niya sa earth. Yung terre na word, which is the French word for earth. Then pag I naman, all live parts are isolated from earth or one point connected to earth through a high impedance. So meron naka-insert na high impedance dun sa common point na yon, So what is the second letter? So ito yung system earthing mo, T sa source. Now, you go to the installation. Dalawa kasi ito, yung red, yun yung source. Then the installation. Papunta na sa installation mo. Then the relationship of exposed conductive parts of the installation to the earth. Kung T yan, it's direct electrical connection of exposed conductive parts to earth independently of the earthing of any point of the power system. So, ang tawag doon, yung pag may T ka doon, then TT, yan, grounded system pa rin yan sa PEC1. Yung TN, grounded system pa rin, So, dalawa lang. Pero dito sa IT, it's the ungrounded system. Then merong N, direct electrical connection of the exposed conductive parts to the earth point of the power system in AC systems. Okay, then subsequent letter, so TN, so meron kang C, ganon, TNC. Okay, then neutral and protection functions combined in single conductor, yung PEN, yung combine yung protective earth mo sa neutral. Maraming applications na ganyan. Sa Meralco, halimbawa, line 1, line 2, line 3, live. Then yung neutral niya, pinapunta dun sa kuan mo, PEN, Okay, dun sa low voltage switchboard mo. Then merong earthing, pinatakbo na dun. So anong gawin mo? Kukuha ka ng neutral, di ba? So i-split mo 'yon. Pero that is TNCS. So let's see the example para mas maliwanag kung ano yung mga gamit nito. So these are the type of earthing system, Sa PEC yan 2.5.4A, this is the grounded systems. So the TN power systems have one point directly earthed at the source, yung transformer. The exposed conductive parts, lahat ng exposed conductive parts, yung mga enclosure, yung mga body, yung mga kwan natin, ng mga switchboard o yung motor, lahat yan. So, meron niyang connection, by protective conductors. Protection ang gamit niya. 3 types of TN systems are considered according to the arrangement of the neutral and the protective. TNS, system in which throughout the system a separate positive protective conductors. So meron kang separate yung PE throughout the installation, naka-distribute yun. Then yung TNC, system in which neutral and protective conductor functions are combined in a single conductor throughout the system. Ito yung PEN. Then the TNCS, system in which neutral and protective conductor functions are combined in a single conductor from the source, then separate, maghihiwalay sila, from TNC, pag the installation mo, kukuha ka ng voltage from line to neutral, so mag-i-split sila. Okay? Let us see some diagrams. So dito sa diagram nito, based on the IEC, ito yung kanila, pag merong line na ganon, neutral conductor, So yung isa naman, protective conductor. Merong horizontal plus slash. Then combined, protective conductor. So sa diagram, yan ang makikita natin para maintindihan natin how would be the installation of the system earthing and the earthing arrangement. Ito yung tinatawag natin na TNS. If you could see the TNS, okay, this is the source. Ito yung source na. Nakita natin, naka-ground yung neutral. So, T na kaagad yun. Di ba? Then, yung neutral niya, kung titignan natin, is separate. No? Line 1, line 2, line 3, N. Naka-separate siya throughout the system. Then, nakahiwalay din yung PE mo. So, medyo maraming cables ang ginagamit mo dyan, conductors. No? And this is how you connect. The exposed conductive part, yung body, makikita natin na nakakonect doon sa PE. Para sa ganon, ito yung tinatawag na banding. So any fault, it will go back to the source. Anyway, ganito yon. The basic principle of how the current is flowing to the load. Sabi nga, the current, no, is flowing from the source, goes to the load. Tapos pabalik naman sa pinanggalingan niya through the neutral, di ba? Line 1, line 2, line 3, load, then neutral. So yung neutral, ang purpose nito is to bring back the normal load current, ano? Yung mga non-linear na loads natin, so merong neutral current. Yung PE kaya protective conductor because this is used, no, for protection sa fault current. Yan diyan dadaan ang fault current mo, hindi dun sa neutral. So you have always to run a protective earth sa installation. Makikita natin may source, may distribution. Maybe this is your main distribution board or low voltage switchboard or yung service, tawag natin, equipment, no? Service equipment. Nandyan. Then after that, installation, ito na yung pumunta sa loob. Then this is how you will run all your conductors in a TNS. No? Then the next one is delta. Pero ito yung kanina, naka-ground yung isa, corner grounded. So how would you do this? You can still run tawag natin, ungrounded conductors. Ano? Doon, line 1 to line 3. Then yung corner, of course, you need still the protective function. Hindi pwedeng wala yun. Kasi kung meron kang line to ground, saan dadaan yung mo, di ba? Yung fault current mo. So you need to return the fault current to the source para mag-operate yung OCPD, yung overcurrent protective device. Then we have here another one, Y, no? The source mo, Y mo naka-ground. Then you have a line 1, line 2, line 3, and the protective earth. Mostly sa 3-phase 3-wire. Ito yung tawag natin, 3-phase 3-wire. Lalo na pag meron ka mga motor, no? Load. Ito yung magiging connection mo doon sa supply, sa source mo. Okay? Then we have the TNCS, which is one factor na kung makikita nyo, doon sa una, TNC, di ba? TNC siya. Yung pen kasi may pen ginamit niya at the same time. So 3-phase, meron siyang PE. Okay, protective at neutral din, dadaan aqua niya. Pero nung pinaghiwalay niya doon sa distribution board, yung N, because he need a line to neutral voltage. So yun, 230 volts for example, then you will run 5-wire na yon. Okay? Merong ganitong installation. Hindi mo pwedeng baliktarin yan, ano? So you have to follow the rules, yung guidelines na ganyan pag meron kang installation. Okay? Now, ito yung very common sa atin sa mga high-rise building. Sa 400 volt system, ano? Okay? Yung utility, kung yung ikaw may-ari ng transformer, you have to do this way. Yung sa utility naman, magbibigay lang siya ng pen saka yung 4, no? Yung ungrounded. So, sa iyo, it's up to you sa installation mo kung i-split mo na yon. But you have to do it the right way. And to avoid yung objectionable current, ito yung pag-iingatan natin not to join again yung neutral saka yung protective earth inside your installation. Ano? Iisa lang yon. Dapat nandun lang siya sa unahan. Ano mangyayari pag kinonect nyo rin sa dulo? Any panel, any load. So, mangyayari niyan, magkakaroon kayo ng objectionable current. Yung return current mo, normal, neutral current, mahahati sila sa protective earth. So, dalawa, pabalik. So, ano nangyayari sa mga data center, sa mga, alam natin, mga ibang commercial? Sabi niya, sir, yung panel board ko, tignan mo yung yung conduit. Nasunog yung mga, nasunog yung mga bushing. Huh? Ba't nasunog? Kasi may dumataan na current. Saan nanggaling yun? Eh, di tignan mo yung load mo, hanapin mo. So marami ako nakitang ganyan. Merong nasusunog, meron yung ginagawa ng iba yung limbawa switchboard ginajumper nilang maliliit na wire para lang daw may daanan yung current. I-earth daw niya yung hindi. Bumalik diyan, live yung mo, yung panel board mo, you make it live kasi na-mix mo yung body, yung exposed conductive part, there is a current passing to that. So pag hinawakan mo naman at hindi maganda yung earthing mo, kuryente ka, di ba? So very careful yung mga installers. Kasi minsan hindi nagbibigay ng shop drawings sa installation. You have to understand, Yun yung training nyo na alam natin na gamitin how to install to install this type of earthing system. Dapat tama, alam na. Pero kung hindi mo alam, o di kabit ka ng kabit, di ba? Yun ang nangyayari. Kaya nakakaroon ng problema sa installation. Nagtitrip yung mga earthing yung RCD mo. Maraming ganyang nangyari sa natin, sa mga installation. Okay? It's very important. Then ito, yung TNCS when it comes to split phase. So malimit ito, ginagamit natin sa Meralco. For example, we have yung neutral ng transformer sa gitna. Naka-earth yun, di ba? Then of course, we have to earth it also dun sa installation natin. Meron pa rin doon, kaya makikita mo may rod pa rin doon, di ba? May rod doon sa poste, doon sa low voltage ng poste sa Meralco, meron din doon sa panel mo, service equipment. So we have to follow that. So ganun pa rin ang concept mo, mapapatakbo ka pa rin. Kung gagamitin mo yung neutral. Kaso sa ngayon, wala tayong ganyan Ginagamit natin yung kabila. Di ba? So line to line. So live yung dalawang wire. So what's the purpose? PE na lang yun. No? Unless sa US, ganyan, meron silang 230 volts, then 1 to 115 yung sa split phase, then they have to do it this way. Sa atin ngayon, PE na lang, protective earth, pinatakbo natin yun. Kaya makikita nyo, merong dalawang hat na sinasabi, merong earthing sa mga outlet. Pero sana, pag binuksan mo yung outlet mo, ayoko nang meron naman nakakonect na protective earth. Hindi lang yung dalawa. Okay? Then we have the TNC. Okay, yan yung wire, how to do the wiring on the TNC system. Then TNCS, when you have a source, at saka yung tinatawag natin na two sources, one generator, the other one is the transformer. Dito yung separately derived system na tinatawag wherein yung generator mo, it's not grounded, but there is only one that is separately derived, yung transformer. Yung ganon. So we have to also to understand yung application. Kasi marami ring nangyayaring ganyan, in-earth pa rin yung sa generator, ano nangyayari? Di ba? So unless you use the proper equipment, katulad ng mga 4-pole, otherwise you will have problem on circulating current. When you are in the generator, babalik yung current mo doon sa tawag dito sa transformer, then meron kang ground fault sensing doon, titrip, di mo matatransfer ulit yung mo from the emergency to the normal supply. So you have to be very careful. Yan naman yung mga requirements If you read on the requirements, then implement mo yan. So ito rin, isa rin ito, yung multiple source system ito. Merong source 1, source 2 dun. Maaring transformer yon. Pero yan, generator yung source 2 dyan. So there are key points here. How to interconnect. Gagamit pa rin ng nakalagay insulated conductor sa neutral. Why? Because we want to focus yung current mo nandun lang sa earthing, hindi yung ashtray na nandun sa cable tray. Bare yung ginamit mo kung saan na pumupunta yung yung flow ng ng current mo during fault condition. So ito naman yung isa, tere-T. Ito ito yung issue sa doon sa natin, sa code natin na kasi ito grounded, ungrounded that the earth is not an effective path for fault current, di ba? Tama 'yon, hindi naman pwede. Gagamitin mo yung earth. Ito yung between the two earthing na 'yon, protective earthing tsaka 'yon, meron kang resistance, di ba? So, in the Philippines, we don't do this. No? Kasi nandun sa code natin na it's not ineffective. So, pag sabihin effective, kailangan. Anong gagawin natin dyan? Di ba? So, kailangan solidly grounded. Kailangan na pag may fault, line to ground fault, kailangan yung OCPD natin, overcurrent protective device, should trip. Magti-trip siya. Kasi kung merong resistance, yung current mo, as you increase the resistance, yung fault current mo, mababa, di ba? So, maaring hindi mo na matrip yung overcurrent protective device mo. So, nahawakan ng tao, merong potential touch voltage na mataas. For example, 115 volts na mangyari, mangingisay ka na. Di ba? So, meron siyang application. Mamaya makikita natin why is it this is very common throughout the world except maybe Philippines and sino pa yung isang bansa? Maybe Great Britain gumagamit ng TNC, no? Walang ganito. But this is the prevalence sa Europe. Why? So mamaya meron tayong mga requirements diyan, no, para magamit natin yung earthing system, no. This is a very good earthing system. The practice of these countries pwede nating i-apply dito, but we have to meet certain requirements, no, dito. Number one requirements niyan, kasi mababa yung fault current mo, then the only way how to do it is to use a residual current device, no? Residual current device para matrip yung circuit. Otherwise, iikot-ikot lang yung mo doon, no? Yung current mo, hindi magti-trip yung OCPD mo, basic overcurrent protective device. Pag nahawakan yung live part na yon, kuryente ka, di ba? So, merong mga requirements yan sa installation. Ito, isa pa rin ito, no? Okay, TT system. And of course, sa DC, this is for the installer, mga PV, battery, meron kayo. These are the guidelines, no, on how to do it. But everything there, lahat ay grounded system or earthed. Puro T yan, no, ang gagamitin. So there are many ways how to do this one. Yan yung circuit niya, no, diagram kung how you want to run, especially pag DC system. Marami na tayong PV, marami na tayong battery. So if you respect the rules on how to connect, then you are sure na makakaroon ka ng safe na installation. Okay? So ayan, TNS, ayan, DC. So these are the ways how to do it. Type B yan. Then we have again TNC. Okay, type A. So itong mga applications nito, these are the best practices gathered by all the national committees around the world, kung ano yung practice. So pinagsama-sama sila rito. That's why itong system earthing na to, it's in the part 1 of the standard because normally hindi nababago yung part 1, Kaya ito pwedeng i-adapt as it is because seldom na nakakaroon ng revision ang part na ito. But now we have a new one now. Lalabas na siya. It will be for approval ng mga national committees yung bagong 2023, na part 1 ng 60364. It will come out soon. So ayan. Okay, I will not dwell on this one kasi wala tayong oras. Pero siguro I don't know if we can continue. Siguro ganito na lang. Let me show you an example as a TT system or kanina sa medium voltage kay Sir Adel pinakita niya yung requirements sa substations, Pero kasi ito it can be used, yung concept niya it could be used because here we are talking about the actual magnitude of current, So ano yan? Wala pang time diyan, di ba? We are directly exposed to the magnitude current without the time element. So ano yan? So kung titignan natin dito, if you look at this one, the value of the current is UO. Ito yung nandun sa sa line to ground, Line to ground voltage. So over the RN resistance mo sa grounding mo dun sa transformer, saka yung sa earth, Resistance mo dun sa ground mo is 10. For example, so meron kang 20. So 11.5 amperes. Kung meron kang fault current in one of the phase, ayaw pala to. Ayaw. On one of the phase, 11.5. So ano yung fault voltage mo dun sa body, so exposed conductive part? This will be the yung RU na yon na nakalculate times the current, nakalculate sa ID, differential ang tawag dyan. So 10 times 11.5, 115 volts. So yun yung exposure mo, which is greater than the requirements na 50 volts. So ito yun, we have to control sa installation natin na 50 volts lang. So how would you control kung 50 volts yun? Of course, it depends upon the resistance. Again, the importance of resistance. Ano ba talaga? 5, 25. Sa Malaysia, pinag-uusapan namin doon during the IECM, 100 sa kanila. 100 ohms. Naku, sabi ko, ano ba yung kwan na yan? Something is, but anyway, we will engage them. They will be coming. So they want to meet yung mga experts natin dito sa PEC. Kilala si Chow Fung siguro. He is one of the, sa Malaysia, recognized na kwan doon sa standards. Then we will be talking about this. Pero as far as this is concerned, makikita nyo, yung 115 volts, wala na, kwan ka na dyan, shock ka na. Pag hindi ka nakabitaw, hindi nag-trip yung kwan mo. So, hindi magti-trip dahil titignan nyo, the fault current generates dangerous stat voltage. Yung SCPD mo is not suitable. Ilang amperes yun? 20 amperes, halimbawa. Kasi ito, nasa final kwan ito, distribution ito eh. Pinakita lang ganyan. Pero actually, itong application is ayan, okay. Then the SCPD is usually, so hindi siya suitable, Kaya nga, wala ito sa PEC natin because mababa na ang gusto nating mangyari kasi, solidly grounded, saka banded siya, continuously, kasi para matrip natin yung overcurrent protective device. Pero pag ganyang TT, mataas na yung kwan, yan ang mangyayari. So, ang solution, yung residual current device. Kasi ito na yun, yung solution dyan. Why we need residual current device? Ito, sa next example, ito. Andun na yung residual, yung CT. Okay? So, the same calculation, makikita natin dito, 5 amperes. So, setting mo is 25, yung OCPD. Kasi minsan magkasama yun sa circuit breaker, di ba? Or external, yung residual kwan natin. Magkakasama sila. Then what happens, residual current device RCD is specially designed for the protection of persons. So, ang tripping condition mo, maximum touch voltage, yung RU times the differential, yung kwan niya, IN niya, makikita natin dito. So, ang touch voltage nito, yung IN niya is 50/10 is 5 amperes. Okay? So, hindi ma-detect ng 25, so it should be your residual. So, that is the importance of having a RCD sa ganitong earthing system. Okay? Why they have adopted this one sa halos sa maraming bansa because of this reason, Okay? Now, going back dun sa kanina, yung permissible disconnecting time, Even you can use this as reference sa medium voltage, yung mga tripping. So IEC, kasi galing din ito dun sa 61140, saka yung yung sa 60479 ng IEC. You see the disconnecting time, 0.2 seconds, 200 milliseconds kanina. Yan ang requirements, na nandyan. You have to disconnect it. As fast as this one, ito yung parameters na value sa TN systems, pwede mong gawing up to 100 ohms. Ayun na. Nakita nyo saan nanggaling yung 100 ohms? Nasa standards, di ba? Kaya si Malaysia, 100 ohms kami. Mabilis naman yung pan namin di ba? We follow naman yung 0.2 seconds Correct. Yan yung basis sa IEC. Okay? Merong mga calculations yan na ginawa. Actually, Sir Adel, in IEC, yung protection against, merong maintenance team dito. I have seen na meron silang bagong gagawin, Maraming experiment yan na ginagawa. Di lang sa tao ginagawa kasi madugo yung talagang mga doktor ang involved, hindi lang ilang engineer when they want to see really yung effect ng currents, pero sabi nga nila, may tao ba? Sige, hindi pwede, very yun, So, yun ang sinasabi nila. So, very important na malaman natin yung requirements ng standard, where it's coming from, Ganyan. Pero yung circuit na ito, 32 amperes, again, we are in the final distribution boards, okay? So yung main features ng TT is protection of person, fault current is dangerous, pero fault current is too weak to trigger the SPD. So protection must be practically instantaneous. So it is provided by specially designed RCD device. So mamamanage natin yan, ano? When it comes to the TN system, ito na naman. Okay? So meron tayong mga calculations, but for the interest of time, makikita mo yung laki ng ang fault current. Ito yung sa PEC natin. The fault current, imagine 3,578. Okay, then kung titignan mo yung resistance ng protective earth mo, with this current, you have again 115 volts. So very dangerous, ano? Ang mangyayari. So ano gagawin mo? Kailangan dito mabilis yung yung protective device mo, no? Na matrip siya within the required na yung 200 milliseconds na yon. Okay? So again, gagamit ka na naman ng why we are using yung 160 CP, then we have RCD, nandiyan na naman siya. So still sa TN system, kailangan mo ng RCD para ito yung ground fault protection. Minsan sa atin, ano? Why we need to put ground fault protection pag ganyan. So if you see at this one again, ito mas mataas, no? 400 milliseconds. Pero you see the condition. Yung resistance, no? The effect of the resistance on following this rule. 2 ohms. Pag ganyan gawin mo, 2 ohms. Ayan, kaya masasabi mo, hindi pwede, 5 ohms. No? Kakaroon ako ng problema. So why? Because this was calculated already considering yung factors, na lahat ng factors dito. Kaya diyan mo makikita, kanina 100 ohms, ngayon naman 2 ohms. No? Yung impedance ng fault loop mo. Okay? These are very important data, no, when we want to do calculations. Okay? So nandiyan yung TNS main features. Okay, ano yung main features niyan? Then TNC, it's all there, but let me show you yung common, ano, yung IT medyo yan. Sa most medical facilities lahat meron naman tayong isolated, ano, so using alarms, mga ganyan. Kasi ito continuity of service, line to ground, first line to ground, you don't open the system, yung supply mo. You have to alarm it para mahanap. So second fault, trip ka na, di ba? So this is continuity of service. Okay, yan, alarm lang ang ginagamit yan. These are the leakage currents, RCD requirements. Then second air fault, of course, nag-trip na. SCPD na yon, ano, ang magpa-function. By the way, ito maganda to. If you could look at the how you would can you mix up? Pwede bang i-mix yung earthing system sa installation? Parallel association of earthing system, no? Saan ang galing? Sa LV mo, neutral, PE, tatlong phase, di ba? Okay, pumunta ka ng TNS. TNS dito. So, i-split mo na siya rito. Pwede yung TNS dun sa taas, sa lighting mo, TT, ano, sa mga machines. Okay? Then you can do IT dun sa isolation transformer. Kaya wala namang IT sa source, mostly sa Meralco, for example. Di ba? TNC or TNS. Pero pagdating sa load mo, maglagay ka ng mga isolation transformer, no, para maging IT yung mo sa load side mo. Then merong series association. This is how you do it. From TNC, pwede ka mag-switch ng TNS, no? Okay, then after that, TT, then IT. Ganon yung function. Itong diagram nito, magandang magamit ito kasi it would give the proper way on how to arrange, no, yung earthing system sa installation. Kasi kung pagbali-balitarin mo yan, sinasabi ko kanina, makikita mo yung problema, no, sa mo. Titrip na lang, merong nasusunog diyan, kung anong mga current na dumadaan dun sa protective earth mo. Kasi mali yung series association. So this is a very important diagram if you want to use this, ano. Ano na ngayon yung ito, yung sino ba mas makakuha sa kanila? Sabi ng iba, hindi, sa amin sa Philippines, TNS, TNC. Hindi, sa Europe, TT kami. Sa Japan, IT. Pero titignan natin yung protection of life, ano? Lahat itong system na ito, they all protect life, no? Yun ang common dito, may protection. It's only on how to address yung requirements ng earthing system. Kaya pwede natin gamitin sa Pilipinas kasi kung titignan natin, it protects the person. Okay? Protection of property against fire, makikita mo. Yung TT maganda rin. Medyo good siya. Bakit? Kasi yung fault current mo mababa. So yung arcing mo, yung fault current mo medyo mababa siya, no? Kaya gustong-gusto nila yung TT na yan. Pero kapag TNC na, sabi niya poor, no? Hindi masyadong sa kuan. Kaya bakit natin ginagamit yung TNC? Bakit nga ba, di ba? Why not we see na yung relevant sa atin, gawin natin. But of course, yung RCD, yung requirements. Okay? Then IT is the most excellent. Kasi first fault current, wala, okay lang. Second fault yan, okay din. So, this one, I will not go further kasi ito, earthing arrangement ito eh. From the earthing system, this is how you will arrange throughout your installation. Yan, yung lighting, LPS na mix dun sa common foundation na grounding mo, earthing system. Okay, yung pwedeng ganyan kasi yan ang sa requirement, yan yung interconnection niya ng lahat ng system mo sa mga enclosures. Protective earth lahat yan, yung nakakonect na yan. Then of course, napakahalaga to avoid any problem on your equipment, lalo na electronic. You have what we call the protective earthing and functional earthing, Kasi pag na-mix up yan, palagi kang kakaroon ng problema dun sa mga electronic mo, equipment. Kaya minsan, we have to understand really, gaground ko ba o hindi ko gaground yun? Ko-connect ko ba o hindi? So you have to know really, sa mga electronics data, for example, you have to, kaya meron tayong functional earthing yung frame, yung symbol kaninang pinakita ni Sir Eric, na meron siyang chassis, ganun yun, functional yun, ang grounding na. Lalo na related sa mga electronic equipment. So this is how you will manage yung connections sa installation. Okay, ito na. Ito na ang decision. Tingnan natin ngayon, nasaan ang Philippines? Hindi. Sino yung kakampi natin? Oh, of course. Sa West Philippine Sea, sino kakampi natin? US and Philippines. Meron sa Great Britain, kaya sabi ko kanina, TNC. Pero tignan nyo lahat. Si India. Baka magbago na rin si India niyan. Mamimit natin siya, si India, later. Yung expert nila. We will discuss about. Mag-switch ka na. Kaya tayo, kita mo lahat, France, Germany, Spain, Belgium, Japan, Norway, sa European, even Japan. Yan ang kwan nila. The earthings. So, yung mga practitioners natin, whenever you go abroad, so tignan nyo yung reference para at least alam na natin ano yung ginagamit nilang earthing system sa installation. Otherwise, it will be nyo, magtataka tayo, di ba? Baka mamaya may apply natin yung Philippines na papaalisin ka agad sa bansa nila. But you have to know really the standards, the regulations na ginagamit. Okay? So, summary, correct selection and implementation of the earthing arrangements are key to ensure, number 1, protection against electric shocks. Pangalawa, the protection against transient over voltages. Reduce EMC effects. Ito yung purpose ng grounding, di ba? Doon sa PEC natin. When you ground, you limit the voltage, yung mga surge because of the lightning, because of switching. Yun ang main purpose ng grounding. Ano yung isa, protection against electric shock? That is the main purpose of bonding because you want to move the fault current from anywhere, go back to the source. Para sa ganon, i-trip mo yung circuit breaker mo. This is to protect. Kaya minsan may nagtatanong, yung grounding ba nakaka-protect sa tao? So tingnan nyo dyan kung saan yung protection against electric shock. You need to have a good earthing system. Yung continuous, completely yung bonding na tinatawag. Otherwise, we have to follow yung requirements ng code na effective fault current path, ang kailangan natin doon. Then reduce EMC, kailangan din yan sa grounding. So these are 3 main points para ma-avoid natin. So ano yung mga standards na to sa 60364 give all the requirements and recommendations for correctly designing an LV electrical installation as far as the earthing system is concerned. Nasa part 1 yung main earthing systems. If you want to go beyond that one, yung paano nyo pagkabit-kabitin doon sa installation nyo, lahat ng kwan nyo, ng banding nyo or whatever, yung electronic parts, functional earthing, then you go to this standard, part 554. Earthing arrangement, ang tawag doon. Okay? Then when there's lightning, of course, there is a separate standard for that related to this, yung 62305-3, where lightning protection system is installed. So dito, there is no unique solution, but difference should be considered to find the most appropriate one. So sa ating mga designers, you have to look on the appropriate. Walang kwan dyan walang masamang tinapay dyan sa standards na yan, sa earthing system ng IEC. So tayo, dalawa lang, grounded and isolated. No? Ungrounded system. Walang ungrounded system. Pero dito sa IEC, pinakita lahat nila yung practice throughout the world. So naiwan lang tayo, since naka-align tayo sa National Electric Code, so nandun. But ang challenge dyan, let's explore further sa future. Tignan natin yung application na ito kasi it will really benefit us. When putting the earthing system sa installation, magbe-benefit tayo. Maiiwasan natin yung maraming problema. So, sasabihin ng electrician, TT yan, alam ko na yan. TN yan, alam ko na yan, di ba? Pag na-define sa requirements. O TNS, TNCS, alam ko na yan. Kung walang guidelines na ganon, kaya meron pa rin mga problema ngayon, simple earthing, na daming problema sa connection, sa installation. Because a simple banding and grounding, nami-mix up lahat yan sa installation. And that is the main problem. No? So we have to take care of this one. Bakit kaya pinag-uusapan pa natin ito? Paulit-ulit na lang yung mga maraming lecture na mga ganito. So this is to remind everyone na we have to do the right way. Kasi ngayon, ang mangyayari sa atin ay ito. Tandaan natin, always I'm giving this as a that it is always permissible to do more than the code requires. So yung mga designer, you can do more if you want. Basta tignan nyo yung requirements. Kasi minsan, wala sa code, wala sa Di ba? Gagawin natin. So the PEEs should be careful. Look at the requirements of the code. Ngayon, kung medyo mahirap, look at the standards. UL is a product, but installation, you go to the IEC. Kung punta ka sa Japan, Japan, wala nang standard dun IEC na rin ang ginagamit nila, di ba? So, let's understand this one, but never permissible to do less than so minimum requirements ang code. Always remember this sa ating mga designs. Now we have to be very careful. Let's do it and check this properly. So, ganyan na lang. Sige, wala tayong oras. Kinuha ko na yata lahat ng oras nyo. But anyway, thank you very much. This is the low voltage system, pero yung application sa protection against electric shock, you could also use this reference sa mga high voltage, mga substations, mga ganon. Okay, thank you.
Thank you, Sir Conrad Binondo, for your wonderful lecture about your topic on global perspective on grounding standards. It is very informative and educational. Okay. So right now, good evening, everyone. We have 400 participants via Zoom and around 250 plus viewers via Facebook Live. So again, we would like to thank our sponsors for this IIEE Tech Talks 5.0. We have Duraplex, wires and cables. American wires yan, Duraplex, right? We have Pilplex wires and cables and Hypertech wires and cables. Thank you very much. And also for our venue sponsor, IIEE. Very good highlight, Sir Conrad. You can go above the code, but not below the minimum code requirements. Tama yun. So, okay. This IIE Tech Talk 5.0, meron ba tayong CPD points dito? Wala. Hindi naman kailangan yun If wala nga, you can apply as a self-directed learning through PRC. Kahit walang CPD, ang importante dyan is meron kang natutunan. Yun ang okay? Now, we proceed to our next topic, on the topic of Panel 4, the overview of grounding system in compliance with the Philippine Electrical Code with our PEC Chair, Engineer Reynaldo Santiago. Sir Ray, magandang gabi. So his topic is about code requirements, key grounding and bonding requirements in the PEC and the NEC, the difference and similarities between the two codes, compliance challenges, addressing common compliance issues during installation, and many more. Take it away, Engineer Ray.
Hello. Okay, yes, thank you, sir, for introducing me. Medyo kinabahan tuloy ako kasi narinig ko parang 600 plus yung viewers natin from Zoom and
Ikaw pa,
Facebook
kinakabahan
Live.
ka pa.
Oo, kinabahan nga ako dahil syempre, iba pa rin pagka marami tayong audience, di ba? Pero by the way, yung mga topics natin that we discussed earlier are very helpful in our practices. So, yung sa akin is more on the summary of those items na lang and then important points based on the Philippine Electrical Code requirements. So, as mentioned earlier, we adopted the NEC 2017 and right now we're developing or gathering inputs coming from all the practitioners for the 10th edition of the PEC.
So we're in the process of updating the code right now.
Yes. So
Oh.
hopefully we could publish or request for the approval of this by the end of this year or even by next year. Hopefully.
Mas maganda kasi it's been how many years na since
So,
the last
2017.
2017? Yeah,
So, yun nga,
almost
kasi
8 years.
we have technological advancement as well. Although syempre itong topics natin are maybe new to some, but maybe masyado ng familiar na for most of the practitioners. But of course, the topics are really helpful talaga, no? So, going to
And we need to also to update ourselves from time to time, di ba? Yung mga recent development,
yes.
mga bagong technology. Kaya nga nagkakaroon tayo ng mga revision ng code eh. Because every year may mga R&D lumalabas, yung mga although yung pinaka-basic dyan is safety.
Yes.
Okay.
Oh, with the development of the technology, so ang mga things to watch out sa next edition of the code is the PV system, new articles, and then the EV charging stations. Yan. So of course, pag sinabing yung bagong topics na yun, merong grounding yan mga yan. Okay.
Take it away.
So, let me
Engineer
start.
Ray.
So, kasi napansin ko, sobrang dami ng mga nakikinig sa atin. Pero of course, syempre, kailangan medyo live pa rin. So, kahit na medyo paggabi na. So, I will not take away so much of your time para dito sa discuss. Pero gusto kong, ito, sikat tong topic na to yung naging news na to. Ayan. Ito yung nakakuryente, yung sa kay Katya Santos. Are you familiar with Katya Santos? Nakuryente yung fiancé niya eh. Kasi, because hindi maganda yung earthing at saka protection niya. Nabalita mo ba to?
Hindi eh.
Kakasal na si Katya noon. Pero ito, yan ang nangyari. Totoo to. You can check this out sa newspaper.
Kuryente yan ha?
Kuryente, yes. Ayan, meron pang link para in case na may gusto nyo matignan. So, that's the importance of this topic is for safety. Kanina nga na-discuss ni Sir Conrad yung lahat ng classic earthing system based on IEC. So, regardless of which type, lahat yun ay for protection or for safety. Okay. Yan. So, para bang may electric fan, may helicopter ba doon sa naririnig nyo? Kasi tabi ko yung electric fan. So, lalayo lang ako konti. So, I'll be discussing the introduction, basic of electric grounding. Similarly to that discussion that was mentioned by Sir Eric a while ago. So, ito nga pala yung, I call our group as Fantastic Four. Yeah. Four. Pero of course, we have the two gentlemen beside us. So we'll be making us as Fantastic Six. Ayun. Six ha, six. Okay, so components of electrical elements of grounding and bonding. So installation requirement guidelines. So common grounding and bonding issues. These were discussed earlier by Sir Conrad. So sabi ni Sir Conrad a while ago, most of the installations that he visited, may mga concerns regarding bonding and grounding. Ilang percent ba, Sir Conrad, yung pinag-uusapan natin na most? 70. Akala ko nagkamali lang ako ng dinig eh. So siguro sa part ko, dahil mas bata ako kay Sir Conrad, pero napansin ko 80 eh. Even higher do sa kanya, no? So we're not talking about age, sir, ha? Yung 70. Okay. So example, strengths and innovation, as mentioned earlier, conclusion, and will be asking a few questions from the viewers. So why ground? So as mentioned earlier, protecting person, facilitate the operation, and ensuring the integrity of digital systems and reliability of data. So earlier, it was mentioned about the magnitude and time. So we'll make that one 3. Of course, the third one is the path. So there are 3 important things to check. Time. Second is the magnitude, and the third one is the path. So tatlo lang yon, regardless of item para sa electric shock. So para rin yan yung sa fire, may triangle, kailangan kumpleto yon. So oxygen, spark, at saka yung combustible material. So this one for electric shock to exist, there must be 3. So kanina lagi ko naririnig from Sir Conrad, even kay Sir Adel right now, Sir Adel. So yung grounding and grounded. So even Sir Adel mentioned about the IEEE standard. So it's very fortunate for us na we're speaking about grounding. Tingin ko, we should, Sir Eric, we should have a series of this topic kasi if Sir Conrad can speak for 2 days about this topic, I can also speak for 1 day. So plus Sir Adel, 2 days also. So plus you, 2 days. Kasi 1 week, 7 days eh. Even Saturday and Sunday. Okay. So these are the components for the PC. So we have metal underground water pipe. So it is considered as grounding electrode. Sa metal frame of the building, and concrete encased electrode or woofer grounding. Yan. Ilan lang yung gumagamit nitong woofer ground. So it was first used in the Middle East. So ground ring, so ground or pipe electrode and plate electrode. You can use the combination of these types. So, kung baga may favorite kayo na isa, samahan nyo na rin ng isa pa. So, if gusto nyo, pakyawin nyo na. So, walang problema. As long as you will be following specific standards and requirements. Like, for instance, it was mentioned that the code requires 25 ohms. So, that's the requirement, but there are specific requirements even as low as 1 ohm. So different applications. So this one, yung sa violation. So this one is not recommended to use, no? One is yung underground gas pipe. Ang delikado. And another one is wala ba tayo pa GCash press? Dito pag nakakasagot. Wala, okay. At dito pala si press. The second one is the aluminum. Okay? Usato. O yan. So, I'll be discussing further yung compliance with the electrical code and then the best practices, safety consideration, and maintenance requirement. It was even mentioned a while ago by Sir Eric about maintenance. So, nabanggit nga niya yung GEM. No, hindi pangalan ng tao na si Sir Jem Tan, but grounding enhancement material. So, to enhance further. Actually, merong nga nung sa area ng Batangas, may utility company doon. Sana tama ako, no? Yung merong nagkaproblema yung grounding system nila sa mga poste. So, they made some adjustment. So, sabi nila binasalang. Meron, ewan ko kung sino nagsabi nun. Inihian daw, kaya nung nabasa, umokay. Pero paano pag hot and sunny day? Paano yung tubig noon? So, nag-evaporate na. So, you have to use specific type of enhancement material. So, may nabibili niyan sa market. So, you will be pouring that material to the ground rod. And it will be, for a long time na. Of course, you have to check once in a while paano siya, kung meron pa rin siyang yung ground resistance niya. Okay? Ayan. Ayan. Ito na. So, yung grounding electrode conductor for alternating currents. Yung electrode, no? So, ang minimum natin is 8. So, yung mga lumang-lumang mga design pa na may nakita nga ako may lumang design. Ewan ko kung sino yun. May gumamit pa ng 5.5 porket kakatwiran is row housing daw. Oo, titipid. Even, sabi ko, hindi, the code requires 8.0. Oo, kasi nga, one thing is para mapabilis yung time. Para do sa source. Ayan. Main banding jumper. Ito, hindi ganong, sabi nga ni Sir Conrad kanina, minsan ito, wire, nagiging pat pa nga ng current yung iba. Kasi kung saan-saan nilalagay. So, we have to check into yung specific locations of the grounding and banding. And of course, if you will be using the type of installation that Sir Conrad mentioned about TNCS, pag sa unahang ka upstream naglagay, it's very, very, very harmful kung nagkaroon ka rin ng combination sa dulo, sa downstream. So this one, and then this one is for the equipment grounding conductor. So the smallest is the 2.0. So ito magandang item to kasi not all knows about this one. Yung alam natin yung parallel, the minimum size of conductor. Yan. Ito matindi. Yung mic sumusuko, ang speaker ang hindi. Okay. So yung sizing ng parallel. Ang sabi sa code, itong very common, nakakaalam. Ang minimum size of conductor sa parallel is 50 mm square. Okay tandaan natin, 50. What if meron tayong voltage drop na malayo? Meron na namang another item that we should consider. Ayan. Babasahin ko pa isa-isa. Increase in size where ungrounded conductor are increased in size from the minimum size that has sufficient ampacity for the intended installation. Wire type equipment grounding conductors were installed shall be increased in size proportionately according to the cross-sectional area of the ungrounded conductor. So aside from the minimum size of wire for paralleling, you have also considered this one. And most of the time, I've encountered while checking this article, minsan kasing laki na ng line conductor yung size ng equipment grounding conductor. Minsan nga nagtataka yung iba eh. Wow, 250 yung size mo ng phase conductor pero yung equipment grounding conductor mo is 250 rin. Di ba usually smaller yon? Check this one. Kasi not all knows about this. Yan. Yan, best practices for installation and testing. Kanina, binanggit yung resistivity ng soil, kaya gravel. So, there is a specific, in case that you don't have a testing equipment, merong mga constant for specific soil condition. Ensure proper installation and measure the effectiveness of ground electrode and bonding system by means of ground testing. So, siguro mas familiar yung iba sa atin, yung ginagamit ay yung 3-point system. So, magbabaon ng rod 1, rod 2, round. Saan ba yung camera pala natin? Saan na magagawi ako rito eh? Kasi, yan. In-on pa, parehas dito. Okay. Tatlo yan. Oh, kahit saan pala ako marap. Sa 2, 3. Oh, yes. Okay. From that one, tatlo, binabound. And then, meron yung rod na for test. But for this one, meron na tayong clamp. Mas maganda kasi wala kang, minsan, mamumblema ka, lahat konkreto na yung lugar mo eh. So, saan mo pa ibabaon yung small rods na yon? Yun lang, mahirap pagka kaliwa. Kanan kasi ko eh. Yan. Ito yung sinasabi ko sa inyo. Yan. Tapos, ang kagandahan nito, kanina binanggit yung residual. There's specific model for testing material, testing equipment that can measure also residual current going to the ground rod. Not only for resistivity alone. Kaya ma-check mo talaga eh, saan nanggagaling yung residual current. From there, kailangan may corrective measures. Tanggalin yung pinanggagalingan or i-correct or ayusin. Ito yung binabanggit ko kanina, no? Sa kanina nagkaroon tayo ng 2 ground rod. So umikot yung current. Yung ungrounded conductor mo yung equipment grounding conductor mo nagkaroon na rin ng current kasama na nung ungrounded grounded conductor. So yung equipment grounding conductor mo nagkaroon na ng current kasi nasama na doon sa grounded conductor. Ayan, ito yung mga usual na ginagawa, no? Sabi nga nun nga sa anak ko eh, kasi may dala siyang laptop. Eh, luma yung laptop na paglumaan ko. So, ang laptop niya is 3-prong. Ang ginawa nung teacher niya, tinanggal yung isa. Kasi sabi niya, eh hindi pwede sa plug namin kasi walang ground. 3rd prong. So, pinutol niya. So, ganyan. Para magkasya. So, sabi ko sa anak ko, sabi sa iyo ng teacher mo yan, pero ito yung proper way of doing things. Kailangan yung grounding is everywhere. It must be everywhere. Sa lahat ng lugar. Walang exemption. No? Even nga doon sa mga switches eh. Ayan, yung sa ground fault circuit interrupter. Ayan. So, by the way, watch out again for the next edition kasi based on our NEC 2023, we have additional requirement for ground fault protection. Ayan, maintenance requirement. So sabi nga ni Sir Conrad, marami siyang mga pinupuntahan. So of course, one is visual inspection. Doon pa lang makikita na most of the installations talaga pinapabayaan. Gamitin ko na yung term na pinapabayaan na walang grounding, no? Tapos yung nagiging problema yung size. So kanina nahapyawan natin yung sizing. And then addressing system failures and safety hazards, failing to measure the grounding system after installation. Kasi meron akong sabi nga nung bata-bata pa ako, sabing gano'n, ang hirap kasi paon yung ground rod. Eh, ang haba nun, di ba? So, hindi na namin binaon talaga totoo yung buong yun. So, ang ginawa namin, kung ano lang yung kaya, pinupok namin, tapos kung ano na-expose, pinutol na namin. Oo, yun, ganun. Eh, meron nga namang ground rod. Pero ang tanong, gaano ka-effective yung ground rod? Ito yung kanina na naman, no? Nabanggit ko kanina. Actually, may naging case na ganito eh. Somewhere in Sampaloc, estudyante na aksidente. Ayan, ito pa oh. So yung neutral kasi nagiging pat na rin. Yung equipment grounding nagiging pat na rin ng grounded conductor. So nagiging neutral. Ayan, dami. Ayan, yung sa addressing system failures, ay, talagang sinusukuan na tayo kanina, Mike, ngayon, monitor naman. O yan, nag-alarm na pati yung ano ko, 9 na raw. Okay. Ayan. Pinakaba si Sir eh. Ayan. Oh, tapos ang pinaka usong-uso talaga sa installation, pagkabit, walang test results. Meron pa nga akong na-encounter dyan sa somewhere in Taguig at saka Makati eh. So naglagay ng ground rod, correct naman ang installation. Pero nga dahil yung pinagbaunan is rocky condition, so talagang akala nila okay na. Eh syempre, inspector, para ako si Sir Jomel, inspector. So pumunta ako sa area, sakto, meron na umpang test. Ang taas. Umabot pa ng 50. Pataas. Ay ko, enhance natin. So, let's place additional ground rods. Lapit na ako mamaya, dito na ako sa labas. Yan. Yan. Kung kanina may ito yung mga defects, loose connection. Importante kasi meron tayong loose connect. Check natin. Kung meron tayong insulation resistance test, meron naman tayong contact resistance test. Titignan natin kung saan yung connectivity niya. Anong babasihan natin na standard? Meron tayong NETA. Loose fittings, missing screws. Usually, meron pa nga ako na-encounter sa breaker. Siguro nawala yung talagang screw sa breaker. So, ang pinalit, yung nabibiling screws sa hardware. Pagka ganun, hindi siya intended for that purpose, ano mangyayari? Magkakaroon ng heating. So, importante, check din yung adaptability ng material do sa item na yon. So, dun mo makikita sa thermal. No grounding bus bar. Yan, usong-uso yan. No ECG in lighting circuits. Yan. Sobrang dami niyan. Kaya dyan, siguro kung yung 70% na nakikita ni Sir Conrad, siguro do sa 80% na yon, nasa 70% nun walang grounding ang ilaw. Inadequate size, inadequate length. Ito, matindi. Meron ako na encounter. Sa panel, makikita mo. Tapos pag hinila mo, 1 metro lang pala. Meron pa ako nakita yung size dahil na-check ko, di kuwari 3.5. 20 amperes yung breaker, di 3.5 dapat. Akala nila, porket compliance, lagay natin 2.0, basta meron tayong equipment grounding conductor. Di na-check. Sir, 20 ampere trip yan, dapat 3.5. Sige, ko-comply kami. Ayan, totoong nangyari to sa may bandang Cavite. Sundan mo yung alambre. 3.5. Uy, umakyat sa cable tray. Patingin mo doon may splice 2.0. So, yun, totoong nangyari. So, sabi ko, galing talaga. Siyempre, nangihinayang na rin sila. Ang laki na nung gagastusin nila doon. Ito nga, yung sinabi ko, ground rod not properly installed. Inter-system bonding missing. Kasi sabi nila, sir, gusto namin, independent kami. Baka kami maapektuhan pag nagka-problema kayo. Bakit? Sa mundong ito, mag-isa ka lang ba? Dapat tayo tulong-tulong. Ganun din sa grounding. Dapat may equipotential. Yan, lesson learned. Ayan, kailangan may mga... Kaya sabi ni Sir Conrad kanina sabi niya, gamitin ko lang yung sinabi niya, paulit-ulit daw niyang sinasabi yung topic na to. Pero ang importante is merong bagong learning. Hindi man topic yung practitioner na naiintindihan to. Yan, kung successful implementation, so ito, may manufacturing facilities, experience frequent equipment malfunction, downtime, so may mga disturbances, so nagkaroon ng grounding system na properly siya nakapag-comply with the code requirements. Trends and innovation, remote monitoring and diagnosis. So mga specific requirement na medyo sensitive. So instead na pupunta ka sa site para mag-test for the ground rod effectivity, so ang ginagawa, nakababad na doon. Tapos may auxiliary contact, nandoon. Sa electrical room, nakikita through BMS. So ganun siya. Ito yung kanina laging binabanggit ni Sir Adel is IEEE 80. So I'll also will mention IEEE 1547. No? And then we have advanced grounding materials with enhanced conductivity. So hindi na lang puro ang ground rod natin will be copper with steel with copper clad. Yan. So these are very important items, especially the grounding. So I cannot go over 15 minutes kasi it's already 9 o'clock. But we're looking forward for this type of topics to be discussed in the near future. And we would like to I'll take this opportunity to thank the IIEE safety community as well as the Metro West chapter for sponsoring this forum. Okay. Thank you.
Thank you, Sir Ray, for that wonderful topic. Okay. So we now proceed to the open panel discussion. Here's our speakers.
Hello.
So it's an open panel discussion, ano? But first, we have a question, ano? Coming from Facebook Live from Engineer Ariel Miranda. Si Sir Ariel from the Bureau of Fire. Ayan, active member natin sa IAE. So yung tanong ni Sir Ariel, what possible electrical safety will you recommend for the sprinkler system and fire detection alarms and communication to be included in the fire code? So it's a general information about electrical safety, ano? So again, what possible electrical safety you may recommend for the sprinkler system and fire detection and alarm and communication to be included in the fire code? Since the design, installation, and maintenance is only mentioned, not of the electrical system. Okay? Pati yung microphone grounded. ano?
Okay, with regards to the question about the fire pumps. So, I've encountered pumps It's more on in our country it's a design by mechanical engineers by law. But for other countries there's a fire protection engineer who handles this one. Pero ito hindi lang siya iisang tao. Fire protection is a collaboration of different professionals. Kaya hindi siya po pwedeng, by mechanical engineers alone. Fire protection eh. So, in relation to the question, yung for the PEC, we have a barrier na ginagamit para for the protection of the wires. So, there's it's either na you can use the fire-rated cables or concrete encasement para at least before masunog, kumaga, it will take time na para masunog lahat. And then, there are a lot of items that should be considered or being considered right now. One is the duration ng ATS system natin. So, there are specific na number of seconds na pag-transfer. And then the other one is masunog na lahat, wag lang yung fire pump. Sabi nga eh. Kaya nga yung type of circuit breaker natin is intended kahit na magkaroon ng fault is aandar pa rin siya. And yung backup system natin kasi nabanggit din yung fire alarm eh. So there must be a backup supply power for our fire alarm system. Kasi ang importante doon is para makadating agad yung first responders natin like the firemen. So yun. Other than that, we're using the NFPA requirements. Yun.
Okay, that's a very nice discussion on the fire pumps, the jockey pumps. I think yung pinopoint out ni Engineer Ariel Miranda will be the probable use of tama na nabanggit mo, Engineer Ray, ano, yung pirated cables, particularly for fire and life safety loads, yung fire detection alarm system, saka yung mass notification system. Kasi you have to keep the integrity of the circuit running during a fire event. So in the probable revision or development in our code, there should be a review para ma-implement rin natin thoroughly yung ganong requirements for fire rating of cables in those fire and life safety loads. Thank you. Sir Conrad, Sir Adel, may maidadagdag ba kayo sa dun sa
Uh,
in
I would,
answering the query of Engineer Miranda?
actually, sa fire protection, I will, hello? Yeah. Probably I will dwell more on the topic, no? Yung earthing system, grounding system na didiscuss natin. As I have mentioned a while ago, yung importance of selecting the earthing system in the installation will help, no, to reduce yung fire, no, sa installation, because where it's coming from when electrical is concerned, yung arcing, no, when there's arcing there in between, yung light materials ang ginagamit mo sa mga kung madaling masunog, no, lalo sa mga areas na medyo hindi masyadong yung materials nila is a light materials ganun. Then ano ba yung tamang earthing system? So nakita natin dun sa slide sa Europe, sa Japan and any other countries, their best practices is to go on yung tinatawag na TT system, ano. Kung makikita nyo why, because this one it will reduce yung fault current mo, no, passing, no, through the installation going back to the source. Mababa lang siya, no, mababa lang, not unlike the TNC na malakas, mataas, 3,500 amperes kanina against ano ba yun, something like 11.5 amperes, no, in the same installation. So makikita mo talaga yung difference when you have a ground fault. Kung meron kang arcing dyan, yung arcing nung 11.5 mas mababa, no? Maybe wala siyang power para masindihan yung materials mo, not unlike yung napakalaki, no. That's why in Europe, sa ibang panig ng mundo, they are using the TT because of this reason, to reduce the effect of electricity, yung hazard, yung arcing, para ma-mitigate yung ganon. So probably we will also look at this solution. Pero may requirements lang, no? For example, some people, they put 300 milliamperes. This is the IEC standard for protection, no, sa thermal effects. Yung 30 milliamperes, not more than 30 milliamperes, is for protection of people. Ganon. So we have to look at this point. Tingnan natin, no? Kasi meron kasi nakalagay sa code natin na the earth is not an effective fault current. Tama yun, di ba? But we have to address also ano magiging advantage. A while ago, we have shown all this advantage, no, of having this type of earthing against dun sa TNC na ginagamit natin dito sa Pilipinas. Yun lang siguro pwede kong i-share reference to our topic for today. Thank you.
Okay, Sir Conrad. Thank you for the very nice input. Sir Adel?
Ako mag-digress ako sa earthing and everything. Meron ako naisip. I'm not sure if we have any doon sa ating fire detection and alarm systems kasi automatically kung meron ka ng FDS systems, doon lang sa local sa control nagkakaroon ng information na may fire. Now, especially when buildings or other building, kailangan mo ba tumawag sa mga fire department eh? Is there a way that we can make this automated na may tawag kagad sa fire department?
There is. So, auto dialer. Yeah.
So I don't know if that's already existing. So kung existing na yan, then it's good. Pero kung hindi pa, then maybe it's one thing that the fire code can mandate to be mandatory. Yeah, hindi pa mandatory na ba yan?
I think I'm not so sure kung mandatory na
So
siya.
nagtatanong si Sir Ariel
Kasi kung may auto dialer ka, sino yung sasagot?
Hindi kailangan sumagot.
Kasi sa
It's just to trigger
kung may
from
compare mo sa US kasi
Oo.
meron silang 911.
911, right? Oo.
So, mabilis yung kanilang reaction
Oo.
time.
It will take long time bago ko matawagan yung fire department eh. So my idea is to automatically send the alarm to the fire department and ma-alert na yung fire department kagad.
Sir Eric,
Yun lang.
do you want to share?
Yeah. Oo. Not necessarily specific to the question of Sir Ariel. Ano? In the absence of specific provision ng mga systems natin available from our Philippine Electrical Code, even to the referring to the NEC, extending to the IEC, ang pinanggagalangin ko lagi as a practitioner is we start with what you call the design. No? Of course, the design should adhere with the right principle, technical knowledge, and of course, yung tinatawag nating standards. Then, walang silbi rin yung the next step natin, yung magandang design, if the standards or the specifications will not be followed. So, kailangan with the right design, you will follow with the right specification. Bibili ka ng mga non-listed or ibig sabihin non-standard materials, definitely your system won't be effective as that. And the third one is, which has always been the third and fourth actually. The third one is actually about installation. Are we doing the right installation? Are we adhering to the standard, the right way of doing things? Including as well yung tinatawag nating yung mga nag-install, qualified ba sila? Are they trained, properly trained? Yun pala, baka naman puro DIY lang yan. O yung tinatawag nating destroy it yourself. Oo. So that's the DIY right now. Kasi if you are an electrical practitioner, definitely you are on the right path because you're protecting your profession. So that, and the last part is yung operations and maintenance. So all of these areas should be a good consideration for a practitioner. It's an end-to-end process.
Full,
When
full
we
circle.
when we consider the implementation of safety. Yan. Yes, sir. Before you add, kung makita nyo, I'm doing highlighting the design. Si Sir Ray highlighting the standards that we have to follow. Sir Conrad is the code that we have to follow. Sir Conrad is highlighting about the standards, the product standards, reference to, of course, the IEC main. And Sir Adel, it's about the operations and maintenance, or from installation and operations and maintenance. So it's an end-to-end process. So as we consider, Sir, may dadagdaw si Thank you.
Yeah, those are good things, na based on my experience audit, I have seen the design is good. Everything, they follow the requirements. Yung implementation also, yun ang naging problema minsan. But nakakalusot because there's no proper inspection and verification on the process. Yun ang nawala. The moment na verify mo yung installation, ginawa na eh. Imagine na, for example, I have seen grounding system. They crimp the conductor using pliers, no? Not flat siya, kaya pag ginano mo tanggal, no? And besides
Methodology,
yung mga banding, they are not using the proper materials. For example, painted yung duct na yon. Then they put ring type na lugs. They tighten it, pero painted pa rin. So there's no continuity
There's a insulation.
of banding of the conductor. So siguro yan na nakita ko rito, yung tama yung design, pero yung during the time of the process, kaya sa IEC meron kami tinatawag na sa level na verification. It is ongoing yan na inspection. Meron din naman tayo nun. Pero palagay ko, doon nagkulang, na bakit nakalusot, then after na commission na, then after the commissioning, nabigyan na ng permit to energize, then after that, may mga problema. Kaya tinawag yung external auditor to check what happened. May forensic investigation. So makikita natin ngayon yung mga problema na ganun pala. Bakit ito? So where's the inspection here? Hindi natin alam kung ano nangyari in between, di ba? So yun lang siguro, tignan natin lahat end-to-end, holistic approach yan, when the installation, tignan natin lahat na ma-meet yung requirements, from the rules and yung requirements standard o ng code, ma-meet siya, design, gamit nila yan. During installation, you are using the right materials na requirements. Then meron verification, kaya nandun na importante na makuha niyan until the final yung commissioning ng project. Okay?
Thank you, Sir Conrad.
Yeah.
Doon sa discussion kanina on using substandard materials, ang tingin ng ibang tao doon, value engineering. No. You're not adding value by using substandard materials and equipment. Dapat you must comply with the standards to add talagang value. Yun ang tawag doon is value engineering. Yan. Okay? May question lang ako sa inyo, Sir Conrad, Sir Adel, Sa mga projects namin, like recently doon sa isang casino sa May Parañaque, bakit yung mga IT professionals, mga electronics engineers, ayaw magkaroon ng equipotential banding yung equipment nila sa electrical system grounding natin? Kumbaga walang equipotential bonding. Bakit kaya? Mas ang ano ko lang sana is magkaroon ng ng informative drive na dapat yun ang tamang gawin. Sir.
Address that. Kasi ganito yun, no? Maraming nag-aaway dyan. Pero alam natin sa installation, the priority is to protect the person, no?
Right.
On the hazards of
Right.
electricity. So when it comes to grounding, no, dapat meron tayong equipotential na grounding na gagawin, no? Whatever is the equipment, either is this electronic, medical, lahat yan. Manufacturer sabi niya, oy, hiwalay mo yung grounding namin. Hiwalay mo dun sa system grounding nyo. Someone should understand in between kung paano ang gagawin.
That's
Because meron tayong tinatawag na protective earthing, ano? Meron namang isa yung functional earthing. Ito yung nagmi-mix minsan eh. Imagine you have a fault. Yung functional earthing mo, yung sa chassis ng mga electronic mo, nilagay mo sa protective earth, ano mangyayari? There's a high current circulation, ano?
Right.
Masisira ka, magkakaroon problema. Yun ang dapat maintindihan kasi hindi lang naman siguro magkaintindihan. But someone should go in between para ipaliwanag. Na in the end, hiwalay mo yan. Kung hinawakan ko ito, hindi naka-ground dun sa system ko sa short, hindi patay yung tao. Pwede mo bang sagutin? That's
right.
a very big issue. So yun lang, we have to separate talaga. Kaya dun sa, merong kasi yung earthing arrangement sa IEC, wherein yung system earthing, okay na, nasolve na natin. Then how do we do it sa installation? Yung mga electronics, mga data. So there are two na kanyan. Pero in the end, they will meet at the main terminal na tinatawag. Magmi-meet pa rin sila. Mababan pa rin sila. Pero along the installation, nakahiwalay yung dalawa na yon. That is called the functional earthing, tsaka yung tinatawag natin na protective earthing. Because you have to protect also the equipment and the person. So ganun lang. Siguro we will dwell on that in the future mga discussion on how to address this.
That's
para
nice.
maintindihan ngayon ni electronic guy tsaka ni electrical guy na sama tayo. No? We have to understand. Hindi yung mag-aaway tayo, masisira. Hindi. May warranty yan eh, masisira. Ganun yung naging usapan dyan eh.
That's right.
So we have to solve this really.
Yan ang
Okay.
pagsasama ng electrical sa electronics. Dapat din nag-aaway.
Tama
Dapat
yun.
nagtutulungan.
During the 90s, the early 90s, when we were putting in the first set of private power dito, yun yung mga panahon na transcending yung analog to digital control systems. And we experienced that issue about the earthing for SCADAs and low voltage control systems and tawag nito data management and everything sa control room vis-a-vis yung power earthing natin. And we experience actual damages ng mga electronic systems dahil hindi nga maintindihan yung functional earth at saka yung protective earth. It turned out that it's a question of kung saan mo ikakabit yung earthing system mo. If you're talking about the PE or which is the protective earth, merong point of connection yan para maband mo doon sa power sa earthing system, main earthing point mo. Hindi mo lang basta ikakabit saan. So ibig sabihin may kanyang tawag namin diyan is may kanyang home run yung PE separated from the functional earth ng power system. Yung power system mo has to be separate completely pag home run mo doon sa point of return nilang dalawa. Nasaan yon? Normally, it's at the Y point of the supply transformer kung may power supply yung electronic system mo. Pero hindi kung saan-saan. That's when you have a problem of the functional earth encroaching into the PEs at masusunog yung PE system mo, which is affecting your control systems. Pag hindi mo nakita yon, yung sabi ni Sir Conrad kanina, talagang magkakaloko-loko yung control systems mo. Lalo na yung mga hospitals, lalo na yung mga, especially SCADAs. SCADA and ITs. Magkakaloko-loko yung IT system mo. Pag ganun.
Thank you, Sir Adel, for that wonderful sharing. Now, we go to the questions posted by Zoom, from one anonymous attendee. Ayaw niya magpakilala eh. Dapat nilalagay mo pangalan mo para sumikat ka. Okay. So the question is, TNCS na common connection, very crucial sa mga servo drive na inverter like Acopos 1090 safety requirements nga pag unbalanced or not properly bonded ang system sa industrial machinery. Hindi ko maintindihan ko kung question to or nag-ano eh. Statement, probably statement to. Kasi walang question mark eh. Now, going to the question of Carl Jam Duruin, Sir, ano po ang recommended na tolerable touch and step potential para sa 69 kV substation? Tinatawanan ni Sir Adel. Kumbaga, sisiw to, sisiw.
I'm not sure about the formula which being defined by IEEE 80, pero nandun yun. It's not dependent on the voltage. It's not dependent on the voltage level. It's dependent on the available fault current of the system. So maybe it's not 69 kV, but your fault current is X. All of that will have to redound to the fault current. When you calculate your mesh and step potentials or task potentials, it's directly proportional to what is the available fault current in the system. Hindi sa voltahe.
Ang IEC requirements for touch voltage is 50 volts, AC, then 120 volts sa DC, 120 sa DC. And bakit ganon? Kanina, pinapaliwanag ko dun sa mga slides about the fault current, na kapag mataas, fault current mo, you will have a touch potential of 115, which is very dangerous. Kasi considering mo yung resistance ng body, 1,000 ohms, ganon. Sa rules natin, sa calculation lang, makikita mo yung current is above yung exposure mo sa fibrillation ng heart mo, kaya mamamatay ka doon. So kung 50 volts, divide mo doon, ilang amperes yun, di ba? Milliamperes, mababa lang. It's below the tinatawag na let go threshold. So we have to always check, ano talaga yung voltahe. Kaya nga gumagamit tayo ng ELV, PELV, extra low voltage, sometimes 24 volts, mga ganon. So wala tayong problema sa mga kwan natin. So isolated siya. So yun, 50 volts is the reference sa IEC. Sa kwan yata pare 60 volts, I don't know, sa kwan natin, sa PEC. Sa CUL, meron silang 60 volts, I think.
Yeah. Thank you, Sir Conrad, Sir Adel, sa inyong inputs. Another question from Engineer John Duruin, Need rin po ba, sir, ng ground yung rebar ng foundation ng equipment, substation, and rebar ng control building? Looks like si Engineer Carl Jam, it's into substation construction, Kaya ganyan yung mga tanong niya. So let me send this question to who will answer? Sir Adel?
Sige, I'll take a stab on the question. Normally, for a substation or control building, which is assumed to be within the same area, and the presumption is meron ka ng earthing mat or earthing mesh around the whole area.
Yeah.
Covered ka na dapat doon. Yung mga siguro narinig mong earthing ng mga foundation bars, normally yan sa mga high-rise. Sa mga high-rise problems yan. Kasi kung minsan yung substation area, kaya yung electrical room area niya, nasa 3rd, nasa 4th level, hindi sa ground level. So normally yun, doon nila kinukuha yun. Para pinapakabit nila yung earthing doon sa mga rebars para kahit paano, bumaba sa lupa yung dissipation niya. But for substations, I don't think it's necessary. Kasi nandun naman na yung earthing. Mas mandatory yung yung earthing mat mo doon sa substation. Saka sa control room area. Yeah.
Okay, thanks, Sir Adel.
Concrete foundation, merong rebars. It can be considered as a earthing grid, And of course, yun nga sa inspection, minsan yung mga rebars tinatalian lang kung GI wire kung whatever. But there are special materials to clamp to clamp the two rebars together para effective. Kasi yun bubuhusan mo na eh. Then no more. Then after that, yung along the perimeter, lalagyan yan ng rods, with the grounding wire, grounding conductor. So these are the system, lalo na yung umakyat ka sa structure, Di ba? Pwede rin gamitin sometimes or yung sa lightning mo yung kwan. Pero you have to see na properly kwan siya, banded. Oh, hindi lang yung minsan kinabit lang na ganun, walang So it's very important sa mga audit na ginawa ko. I have been looking. Meron ba kayong photo? Kunin niyo ng photos kung kwan, no? Na ban ba talaga ito?
Yeah.
Minsan di mo na alam,
Oo.
binuhusan na.
Para may photographic
Oh,
evidence.
yun ang pinatate sa inspector. You have to do photographic evidence para may record ka na sumunod sila talaga. Ganon, no?
Okay.
Okay.
Thank you, Sir Adel. Once more, and Sir Conrad. Ano pa ba? May question ako coming from my end, Sir Ray. Di ba yung Philippine Electrical Code natin may article doon about lightning protection? Saan ba siya derived? Nasa NEC ba talaga siya? Or adapted from what standard? Then follow up also, since nandito rin si Sir Conrad sa Standards Committee, sa mga projects, I don't know kung Sir Ray ginagamit yung NFC 17-102, di ba? Yung French standard dun sa early streamer emission lightning protection. May chance ba yun na may lagay sa ating PEC as pangalan nito, supplementary code sana or additional information? Kasi nasa PEC natin nakalagay doon mga conventional type, di ba? Air terminals na conventional. Thank you.
Yes, ako. Ang ganda nung tanong mo, sir. Kasi actually, we've discussing that one as early as 3 years ago in relation to the early streamer. So we're looking at including a part of the code na mentioning about different type of lightning protection system.
Yeah.
Similarly to the early streamer. So that kasi parang baka nga for the projects baka ang gumagamit lang ng conventional lightning rods are about 10% lang
Yeah.
So the rest are early streamers So ang tanong does the code allows yung wala naman binabanggit na dini-disallow. Kaya lang mas maganda nga naman na mailagay sa code na it allows.
Yeah.
Sa yun, we're discussing that one and then hopefully we could include that one specifically mentioning the early stream.
Yun. Kasi aside from yung conventional nga, andyan yung early streamer, dissipation type array system, and many more. Faraday cage siya.
Streamer na yan, there is a Korean technology. Of course, they have tested this one na pati yung grounding niya, hindi na grounding rod. There is a grounding tawag dito, yung parang carbon
Okay.
rectangular
Ah,
and it's embedded there. So anyway, whatever, you have to test yung grounding resistance
that's
na
right.
required, yun pa rin. So kung effective yun. When it comes to IEC, of course, ang product standards dyan, I'm not so familiar kung ano yung ginagamit nila ngayon, but when I was in Europe, I have seen air terminals. Sa Malaysia, air terminals.
Air terminals.
When I was in the Energy Commission nung sa Suraya, this is the one controlling the quality, the safety sa Malaysia. I have seen their buildings, lead building na yon. Pero if you see the one, palang air terminals lahat. And they don't use grounding yung conductor na katulad ng they are using the grounding bars. Yung banding lahat. Rebars, ganon.
Sa perimeter
Hindi yung
ng
wire,
group
hindi yung
siya. Copper bars. Copper
bars talaga, flat bars,
Flat bars.
diretso, wala sa lahat yan. Yun ang practice nila doon. Ground bars. Yun ang down conductor, makikita mo. So that's their practice na talagang wala yung mga early streamer. I think the early streamer is prohibited sa US.
At a certain level, they're actually using the air terminals. But I don't know if there's a consideration of study na lightning-stricken area ba yan? Madalas ba? Diba? Just like what happened. Nakita natin parang sa YouTube yung sa isang football field. Pero isa natamaan ng lightning, then everyone falls down.
Actually, yung sa lightning, meron tinatawag tayong lightning risk assessment na kinoconduct ng isang lightning design professional.
Merong
Pero
isang-
maganda
merong-
dito, ma-practice rin natin yon in the local scenario.
Also ganito, no, when you move around, be a like a roving auditor, no?
Mm.
Para yung meron sa US, 'di ba, yung roving violations. Siguro gawa tayo ng ganun, tignan natin ano yung mga installation na makita natin. Kahit lang sa visual. For example, I have seen dyan sa dito sa naiyak yung mga hotel dyan, ano. Hindi ko na babanggitin, pero I was there 2 weeks ago. Nakita ko yung lightning niya, early streamer din
Yeah.
ang ginamit. Doon sa gitna, malapit sa swimming pool. Merong building siguro may equipment, no?
Mm.
So nakatayo siyang ganon. Pero yung paligid niya, matataas na building.
Mm.
So imagine, ano, this type, sabi ko, my God, what is this type of installation? Sino ba nag-allow dito na?
Mm.
Wala. So,
Baka
ha?
nung una, sir, siya lang yung unang nandun.
Hindi,
Oo.
nandun na yun.
Diba?
Yun ang ginawa.
Hindi mo,
Hindi
hindi
siya
mo kasi
unang-
pinabanggit ko anong hotel yan. Eh.
Hindi,
Six
I
star
think,
ata
sir,
yan eh.
6-star?
I think Sir Conrad, baka
Siguro,
yung
siguro.
yung nakita nila kaya naglagay sila ng sarili. Kumbaga, ang principle na you have to protect
Protect
your
your
own. Kumbaga, in analogy, parang kanya-kanya tayong dala ng payong. Hindi ka sure kung yung payong ng kabilang building is kasamang napoprotectionan yung building mo. Okay. Yeah, level, kung level 1 yung protection mo, mas maganda. Pero baka may yung design nung building na yon level 2, level 3, di ba? Kaya yon. Nakakamiss sa mga ganitong panahon si Sir Bobby Ocampo eh. Sir Bobby, shout out ito para sa iyo, no? Kasi pagka nandito siya, kung umattend siya, marami siyang tanong sa grupo na to eh.
Si Anonymous.
Ah, okay, sa practice array, isa pang tanong ano mas 'di ba maraming grounding electrode pwede kang steel, copper clad steel o kaya stainless steel. Sa experience mo, ano mas maganda sa tamang application? Kasi like kung malapit sa dagat or stainless steel ang pinapalagay.
Oh,
Yes.
yes.
From your end, ano yung masasuggest mo as a designer?
Oh.
Kunyari, hindi ako designer.
Without considering yung environment, no? So, ang tinitignan one is functionality, safety, and reliability.
Yung.
Yun. So, syempre, ang hirap baon yung rod eh. So, I'll make use of the steel. But, coated with copper.
Copper clad. Yeah.
Copper clad para medyo cheap but reliable din naman. And safety naman. So, the three, kinokomply niya yung tatlong items for good design.
Okay. May other inputs kayo dun, sir, sa Yung upper grounding ba? Gusto mo paggamit dito sa Pilipinas or applicable ba siya o hindi? Upper yung concrete and case Okay, with that and
Question, sir. Sa anonymous question from me. No, sir. Basic lang po. The commercially available people protection is rated 30 milliamperes. So 300 milliamperes po sa equipment. However, yung presentation natin, yung threshold natin is 9 to 25 milliamperes. 9 to 25 milliamperes is let go na siya eh. So shouldn't we be influencing yung market para yung available na 30 milliamps, babaan nila para pumasok doon sa para bang threshold? Your opinion, please.
Okay. Yung kanina, yung pinakita ni Sir Adel, on the various level of the magnitude of the current thresholds, makikita natin kung ano yung effect. That is direct contact. No? Direct contact doon sa installation, yung various level. So, mangyayari yun. Then, doon nga sa requirements standards, yung 60479, you have to consider yung time element for disconnection. Yung pangatlo kanina, yung path, di ba? Yung body. Mga ganon. So, sa IEC standards, nakita nila, why 30 milliamperes? ang sinabi doon sa standard, not more than 30 amperes. So you can use 30 amperes below. Pero anong naging issue doon? Why they don't use 4 to 6 milliamperes? Because sa Europe, is 400 volts. So 230 volts ang potential voltage mo, line to ground, is higher than sa US na 115. So ano yung kwan mo doon, yung mga current kwan mo, mababa sa kwan, 115 volts eh. Sa Europe, it's 230, which ginagamit natin yung 230 volts. Yung line to ground or line to earth potential. So, kapag gumamit sila nun, 4 to 6, pwedeng gawin because the requirement is not more than 30 milliamperes. So you can go 30 milliamperes, you go 20 milliamperes, which is available, you go 10 milliamperes, available lahat yan sa product, but depende dun sa voltage na ginagamit mo. Ang nangyayari dito, nung nag-usap-usap kami sa IEC level, naglagay ng minsan 4 to 6 ganan sa installation. Trip ng trip yung kwan. Yung anong ginawa? Tinanggal na lang. So, nakita ng mga experts na why not na itaas natin sa ganitong level. Compromise. Okay, protection. Okay, so they decided to go with 30 but they don't prohibit to use 20 or 10, no? Ganon. Then they have to follow also yung 20 milliamperes, 30, mataas na yun, di ba? Pag nahawakan ko, patay ako. Pero merong speed. Yung disconnection time ng device which the product standard has to consider. For example, sa 30 milliamperes, it's 200 milliseconds. The product should comply to the requirements of the installation na, ikaw, gumawa ka ng ano. Actually, yung product standards na ginagawa is not exactly 200 eh. Mas mabilis pa eh. No? Pero, yung magnitude of current mo, threshold mo is not more than 30. So, everything 30 below, talagang madedetect niya yan. No? So, ganun yung kwan dyan, yung concept dun sa threshold, yung detection.
Ako,
Current.
in addition doon sa sinabi ni Sir Conrad, I'll just add, no. We both agree on the path, the time required, tapos yung magnitude. Yun nga lang, ang difference ng PAC with the IAC is that we have different values. Yung magnitude iba sa amin, iba yung time namin. Magkaiba kaming dalawa. So, depende kung European guy or IEC guy ang kausap mo or
No,
Amerikano ba ako?
no, actually, with reference to that, no, yung kanina, IEEE, this one, we can check it later sa ibang discussion. That IEEE have used, ginamit nila yung reference na 60479 sa IEC. If you go to yung mga studies sa USA, ginamit din nila yung IEC study dito sa kwan na ito, sa mga kwan nila. No? And sa UL, meron silang formula na ginagamit. Kung titignan natin yung formula of the UL dun sa current, no? Threshold current, similar lang. Kasi yung IEC, ginamit din niya yung pag-aaral ni sino yung father of the 30 milliamperes, yung nag-create ng GFCI, yung American. Hindi, I forgot the name. Sa Europe kasi si Weishilmer sa Australian na siya, scientist na talagang in-experiment lahat nila yan sa human. Kaya kung makikita mo, may number of populations na sinubject nila sa current, na hinawakan talaga nila yon sa experiment. Then, mayroong babae, mayroong lalaki, mayroong bata. So they created a path, yung curve, no? Yung curve ni sa USA, saka yung curve ng Austrian, si Weishilmer. Kaya nakita nila yung various na effect ng current sa human. Ganun nga. Pumunta sila sa formula na halos pare-pareho sila. The same ang kanya approach. Okay.
Simple question lang in relation then complementing yung tanong kanina ni Sir Manny. No? It's more of actually yung mga materials na ginagamit natin. Kasi we're talking right now of actually yung mga standards implementation. And along the way, it's very important then na yung type of material that we're using is actually has a very important role when it comes to safety and protection. So sa code natin, is there something like a policy or a restriction na tinatype approve ba natin yung mga dumadating na materials sa atin before we actually recommend it for use?
We call that one as listed.
Yeah.
Listed. Which is defined doon sa chapter 1.
Okay.
Another question, yun nga kasi nagkakaroon nga tayo ng mga sinabi kanina ni Engineer Tamundong, na yung mga DIY natin eh. Yung mga DIY natin yon, no? Yung mga ganun na it's actually happening, and this is most likely the cause of really yung nagkakaroon tayo ng failure ng ano eh. So how do we actually control at regulate yung mga pagpasok ng mga ganong ano na dito sa
Of course, napaka-importante yung regulation when it comes to the product that's coming into the Philippines. So ang regulating agencies yan, sa consumers, we have the Bureau of Philippine Standards, no? So lahat yan, especially yung mga products related to the consumers, yung mga sa dwelling places natin, no? Yung mga ordinary persons gumagamit. So what is that? Yung mga washing machines, yung mga kuwan natin, heaters. So lahat yan. Then a certain range of circuit breakers, no? Para sa mga distribution boards na maliliit until I think 125 amperes. Merong regulation diyan. May Philippine National Standard, then merong testing agency, third party, to validate yung equipment. Pero this is based on certain standards, like for example IEC, yun ang nasa BPS. When it comes to the other materials, walang kwan dyan eh, walang regulation. Yan ang naging problema, selected lang, very few. So maganda siguro na we have adopted a lot of Philippine national standard is available sa BPS. The only thing is sino kaya ang pwedeng gumamit doon para magamit as ma-include sa regulation. Yun ang napakahalaga doon. Unless na ginagawa yon, kanya-kanya tayo rito. Lahat export. Merong tinatawag na minsan yung certificate na i-inspectionin doon sa factory nila na manufacturer, wherein katulad ng may mga marks ang BPS, di ba? Kung wala ka naman testing na gagawin, you could possibly visit the one, then i-certify mo doon, no? Pero halos marami tayong issue dyan yung sa regulation. Ilan lang yung nare-regulate sa electrical. Selected yun, meron tayong dyan, listahan. Kung wala doon, hindi regulated. So it's up to the practitioner o yung the standard of the product. Yung katulad ng sinasabi mo, sabi niya, listed. Kumuha ka ng certificate, no? The grounding rod and everything, yung mga listed na mga clamps sa grounding, alam sa grounding. Okay, give me UL listing. Hindi yung walang marking, ano ba to? Saan ginawa? Baka dyan lang minolded. Yun ang problema, di ba? So yun ang guide lang. Then sa IEC, check to it na mayroong product certification following certain standards sa product. Makikita mo naman yan kung ano yung related Huwag lang yung basta nang nakapaglagay ng standard, meron ganyan, nakita ko, gusto ko nga, yung standard ito. Hindi naman related dun sa product na yun, basta nilagyan lang. So yun ang isang, if you are not familiar with the standards, yun ang problema. Kaya kung mitikuloso ka, tignan mo yung marking mo. Yan ang napakahalaga. Kung walang marking, magdalawang isip ka na. No?
That's right.
Yeah. Yun lang ang guidance ko sa mga natin.
Sir Conrad, I'll add to sa nabanggit mo in relation to the Bureau of Product and Standard. No? Unfortunately, we don't have testing equipment right now to address all of the items na available in the market. We have a few, no? As breaker, meron tayo up to a certain rating. And then the rest, BPS relying on the certification coming from the manufacturer.
Mga type
So,
test. Yeah.
dalawa yung classes. Certified through a standard, and the one is compliance only. So, minsan nalilito yung iba, no? And users, akala nila, oy, compliant. Yung UL compliant, may nabasa pa akong ganun. UL compliant. Pero ibig sabihin, self-serving yun. Kasi yung sarili niya, nagsabi, oy, nag-comply ako for this specific standard alone. But if you are certified, that means there's a third party who tested your product. So, you have to check into these specific documents that you have to check.
Okay, thank you gentlemen. Time check, it's 9:52 p.m. already, So, yung mga questions in Facebook, sasagutin na lang ni Sir Ray through email. So, with that in taking in consideration, I would like to request Final thoughts, final words of wisdom as to our topic on Tech Talks, safety practices on grounding system, code compliance, Tech Talk 5.0. Sir Ray, last few words.
Few lang ba o a lot words?
10 seconds lang.
For the grounding, it's more of safety. And grounding must be everywhere.
May iwan ko lang sa practitioners natin. Let's not mix up no yung purpose ng banding and grounding. No? We have to understand that yung grounding, according to our Philippine Electrical Code, is to limit the voltage to earth during lightning, switching surges, lahat. Yun ang purpose nun. But to protect the people against electric shock, there should be a continuity of connection among the exposed conductive part going to the source. So yun tinatawag na banding. Huwag natin pabali-balit na rin yung function. Otherwise, we'll have problem. That's all.
Naunahan mo ako doon. Okay, may backup ako. Yeah. This is what I've always been trying to tell our practitioners, no. Kung in doubt tayo doon sa isang bagay, especially earthing and even design, I always advise that you have to always lean to a certain standard. Kung ano yung reference standard mo na inassume mo sa ginamit mo sa design mo or sa installation works mo. So kung hindi ka sigurado, try to find a reference where you can lean on para sigurado ka. Hindi yung pwede na to. Medyo matugo yung pwede na to eh. Yun lang. Thank you.
Thank you, sir. Siguro all of the above na lang yun. Seriously. Thank you for this gentleman, supporting the electrical safety. We are, siguro yung message here is that as electrical practitioner, we are the frontliner of electrical safety and practice. So we should walk the talk. Sabi natin safety. Yes, it starts with the concept of doing it, then to design. Sabi ko nga kanina, to design, then to procure or doing the standards, bibili ka ng material, no? Hindi po, natuwa tayo, ang gaganda ng mga material na nakita natin sa market. No, murang-mura, ang ganda na, aesthetically very good, Xing yung brand. Wala sa standard, and then of course, we follow everything, basta kaya po meron din tayong Philippine Electrical Code, and then we have the RA 7920 who supported that electrical practitioners, the licensed electrical practitioners are those people who are actually implementing quality, reliability, and safety of our system. So with that, kailangan ang electrical practitioner, electrical safety always starts with me. Yun lang po. Maraming salamat.
Thank you very much, gentlemen, for the very educational and wonderful Tech Talk 5.0. Sabi mo nga, Sir Eric, it's wonderful tonight. Okay, again, we'd like to thank our sponsors for this Tech Talk 5.0. Duraplex Wires and Cables, Philplex Wires and Cables, and Hypertech Wires and Cables. So, at this point in time, let me award our technical panelists this certificate of recognition. The certificate is proudly presented to the following panelists: Engineer Eric Tamondong, Engineer Reynaldo Santiago, Engineer Conrad Binondo, and Engineer Adelino Garcia Jr. for their expertise and knowledge as our technical speaker on their topics during Tech Talks, Safety Practices on Grounding System and Code Compliance Requirements 5.0, given this 14th day of November 2024 at IIE Building, Monte de Piedad, Cubao, Quezon City, signed by our IIE Metro West Chapter President, Engineer Henry Binrao. and signed by our Chairman, Electrical Safety Committee, Engineer Eric Tamondong, and signed by our IIEE National VP for Technical Affairs, Engineer Jedper De Castro. Congratulations, gentlemen. Video. Sa Metro West, you're the best. Ulit. Sa Metro West, you're the best. Thank you. Thank you, sir. Now we proceed to the closing remarks by our IIEE Chairman of the Electrical Safety Committee, Engineer Eric Tamondong. Sir.
Okay, konti na lang po ito. Thank you everyone sa more than 400 participants at Zoom. And of course, kasama din po yan yung mga nanood din sa Facebook Live. Thank you for all supporting the IIEE activities for 2024. And don't forget, magkita-kita po tayo. We have a couple of activities for different committees. Lahat po halos ng committees ng IIEE National has its own activity in the annual National Convention this coming November 27 to November 30. Actually, I don't know if it's hanggang December 1, 2024. And we look forward to always your participation. We're actually improving and it's always a work in progress. So kung medyo may konting pagkukulang ang bawat committee, ang bawat isa sa amin, serving you hanggang ngayon, hindi na po nagsasawa ang IIEE para sa inyo on behalf of those people behind this activity and all those you. Kasama po kayo sa mga nagsuporta sa IIEE activity, your participation. Again, electrical safety starts with me. Ligtas Pinas. Maraming salamat po.